Hello, hello. Hello. And today, the plan is to do the advent of code. Hello, Nerdsoul. Was day one easy? Day one is always easy, right? Because it is day one. I mean, usually day 12 is also easy. I mean, it's like always easy, you know. Like advent of code is easy in general. I guess. uh, Oh, you mean like was it easy to do it in cast? Yeah, I mean I was missing some features, but I improved the thing, right? Like I added stuff to the language. Nothing major was missing though, I guess. I mean the most important thing that's missing right now is like lists, right? But I was doing the trip for that reason, so that we can use trips instead of lists, right? So yeah, don't really miss anything currently. Um Advent of code, let's go. All right, day 2. The gift shop. Let's get into it. Hello, Veldak. This is the stream. That is one of these streams. You get inside and take the elevator to its only other stop, the gift shop. I forgot the story, the lore of the previous day. We were like unlocking some safe or whatever. Thank you for visiting the North Pole, gleefully. What does this even mean? Gleefully. Gleefully means in a happy, excited, or delighted way. Gleefully explains a nearby sign with glee. Hello, penguin. Yeah. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here, and from there you can access the rest of the North Pole base. As you make your way through, As you make your way through this surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They have even checked the most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you will need to check. For example, 11 to 22, 95 to 115 and stuff, right? So here's our input. Let's start with that immediately. Let's open the code editor. Advent of code. We go day 2. Example txt, right? That's our example input. The ID ranges are wrapped here for legibility. What do you mean wrapped? In your input there, oh yeah, okay, makes sense. It's just a single long line. The ranges are separated by commas. Each range gives its first ID, and the last ID is separated by a dash. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 55, 5 twice. Wait, what? Hold on. My reading is really difficult. And like remembering what I just read. Since the okay, we can find the invalid IDs by looking at any IDs which is made only of some sequence of digits repeated twice. Only of some sequence of digits repeated twice. Oh, I see. Like, yeah, so like the left half and the right half is the same. Okay, makes sense. Is there a source code? Yeah. It's not in the cast, I just made my own repo here. Kuhiman, Advent of Code 2025, yeah. Let me put it here. Let me put it maybe like here too, if anyone else wants to look at that. Right? Did you solve the day one yourself, or are you not doing Advent of Code? GitHub detects cast as Kerberos script? Yeah. Okay, let's continue reading. Alright, none of the numbers have leading zeros. 0101 is not an ID at all. 101 is a valid ID that you would ignore. Your job is to find all of the invalid IDs that appear in the given ranges. In the example above, we do this, and then adding up all invalid IDs produces this, right? So we need to add up all of the invalid IDs. I feel like this is easy. Maybe like there is some like things that like with strings that we need to implement probably, because my standard library has nothing almost. Yeah, this is like really, this is easier than day one, I think. I mean, no, day one, part one was also easy, right? Part two also was easy, but I was like struggling with it for no reason, I guess. Whatever. Yeah, let's just see how we do this here. Like the main purpose is not like because it's difficult, but because I want to improve the language, right? That's why we're doing it here. Like one of the things that I want is this to be detected automatically, I think. In my LSP, I don't want this to be like listed manually here, but for now, that's what we do. These are all the workspace roots so that the LSP knows about them. So now I can have actual like syntax highlighting here. All right. Part 2 for day 1 was a bit tricky compared to this, yeah. Okay, let's remove this. Actually, like this stuff should be going to the standard library of my language. Changing the directory probably could go into the common stuff. Hello, Nigel. So this over here is when the solution actually starts, right? Yeah. Let's get rid of all of that. I mean, let me do this. If I use the plus equal, minus equal, or whiles, then I will move that into the standard library, I guess. So we want first to read the input, right? Let's make function read input, right? I mean, or we can just say std fs read file. Is that a thing? Yes, a read file input path, right? That is our input as a string. Why do you have no empty lines? It's hard to read. Because my formatter does not preserve the empty lines for now. If you want, you can do a pull request that preserves the empty line in formatter. The only way I can do like the empty lines right now is by doing the comment, I guess. Empty line, like this. Yeah. Otherwise, if I try to do like something like this, and then I do the formatting, it removes the empty line currently. Yeah. I mean, is it hard to read? Where would you put an empty line here? This is a crime, we need to fix it. Yeah, maybe. I don't know, maybe we can do it today. We'll see. Let's first solve the thing and... yeah, you know. So we read the input, then... I need to like split, right? So one of the things that I don't have is string... string. We don't have splits, right? stdlib. Oh, wait, I cannot... okay, so when I'm working in my, like, I can go to the standard library, but I cannot, like, my LSP does not work in the standard library, which is in the Nix store here. Okay. You will pull request? All right. So in the string, we just have substrings. We can iterate over a string. We can do index of. We can get at and like, yeah, last index of. Yeah. So we don't have a method to split the strings, right? So let's do this first in this. To do should go in std, right? String split, right? What do we want here? What is the function that we want? We want a function that splits string over the separator, which is what? A string 2, I guess, right? Or do we split over a character? Over a character is like a little easier, right? I can do that first. Or expected a type got error. Could not find char in scope. Wait, do I not have chars? Wait, what? Char? Oh, it's not in the prelude, I think. Yeah, it's not in the prelude. Let's say use std char. Okay, now that works. And then we say this should return. Well, I mean, this should be like an iterator, right? We don't really have iteration, so we will have like a function which takes a string and returns unit, right? The consumer of the splitted things. That's what we want. We don't have units. I'm not a camel. We do this. All right. One of the problems is that my LSP is twice as slow when I have this. I should comment this. And then my LSP is going to be twice as fast, actually. Yeah. I'll just return a list of characters, a list of strings, right? Because I don't have lists right now. And it should be an iterator. Anyway, like the method in Rust returns the like the iterator, right? You did day 1 without list, yeah. Well, I mean, I am using trips, which is how, like, what we use instead of lists, basically. String, okay. So what do? We say that, like, start is 0, right? And then we do string iter. Can I open the string? We have iter I, right? Which has index and character. Iter I as, and then we have function, index, and character, and we do something, right? So if we see if character is the separator, then we do split, right? Otherwise, I don't do anything. Yeah, split I, and then we have the split here. Why is this red? Assign must be expression. Type check fails. String is not string. Iter I string. My LSP like is a little weird right now. I need to fix it. Split is a function that takes index, and we split at this index starting from the start, right? So then we will say start is index plus 1. Wait, actually, you know what? I already have this. I already literally have this in the standard library because we have lines, right? That's what we have. We have lines. It's literally this. This is my implementation. Because lines is just splitting the string over the new line, right? So I should just move this into the standard library and make lines be using this the splitter, right? So this should be like substring iterate, and then we do length of s, and instead of like this being end line, we just call this like the actual like you know, I don't know, like perform split or something. Why is this native minus? That's a little weird. That is because before I implemented shit, I think. So we just do I minus start here. Yeah, there you go. It is still nixing into the project directory. The cast project directory. Well, I mean, it's going to download on your dependencies, right? And some of them should be compiled too, I guess. Maybe. I'm not sure. I don't remember if everything is in the cache. Okay, so yeah, we just don't call this line. This is like when we split, what do we call, like part, right? And we call the function with the part here. GCC is doing its thing. Are you building GCC? Wait, like you should not be building GCC yourself though. That's weird a little bit. Or like GCC is compiling something. Maybe you're compiling a camel compiler for some reason. Yeah, maybe it's because when I don't know. I don't remember. Because I updated to OCaml 5.4 or something. Okay, so this is the string split, right? Now we can now we can use the string split, right? So we do string split. We do string split of our input using the comma, right? yeah, I need to give it the function now. So we have the part. So this is going to be like ranges, right? This is our ranges. Why do we have /n in the split? Oh, it's because, yeah. I should have like warnings that a variable is not used. That would help me, right? It's because I copied this from the implementation of the lines, right? And there's a more general splitter. Yeah, separator. I should add warnings to my LSP, so like if the thing is not being used. Type check failed. String is not character. Wait, what? Oh, there we go. Yeah, I need to like fix it so that I don't need to restart my LSP all the time. That's weird. Okay, so this is a range, and then we need to like figure out what the range is, right? So range has the dash inside, so we need to do that too, right? So and for that, I guess we need to have the string split like once, right? And that is actually the thing that is going to give me the two strings back, right? That's a little bit different. So we just go over the string, and then we say that if this is equal to the thing, then I just return, right? And over here we just say like panic, because this is not found. Perform split is not perform split. We don't do else. Over here, yeah, we just like return. We don't have returns from functions yet. Maybe I should have it always, but we have unwindable. Block. And then over here, I would just unwind block with string sub string as 0i. And substring as I plus 1. String length as minus I minus 1, right? Something like this. And panic is like over there. Does unwindable implement? No, unwindable is just the it's just a named block, so that you can break out of it, right? Source day 2 main. No cast direct allow. Okay. So that worked. Let's just print over here A and B. I guess like start and end is string split once, range using the character dash, and then we do std dbg print start and end, right? Something like this. Let's go. So this is all the stuff. It seems like I have the /ns here. So maybe I should also, yeah, because like, yeah, that makes sense. So I need to like also trim, maybe. That would be another good thing, right? To have a string trim. You know what I should do? I should just say that string is like a module or whatever, and then we use a string, like we use string dot star, I guess, std string star, something like that. So I would say string dot like right inside of this. So yeah, I want to, yeah, and then I don't call this string split, I just call it split. I call this just split once. I call this trim. So over here we just say string.split. That. So over here, trim is a function which takes string and returns the string back. Okay. So then I just should say something like string iterate. What do we do here? So I need to find. Wait, what is it saying? Function type cannot be an expression. Oh yeah, yeah. I need yeah. Forget the syntax. Maybe like I should. I don't know. I'm not sure if I like this over here, but I don't know. We can change the syntax later. Inference failed. String is not unit. Yeah, yeah. Like, where's my language server? Yeah, there we go. Now it is saying that I'm not returning a string from this function. Okay, so we have a character. We need like also something like module char, right? And then we will have like is white space is going to be another function. We watched Bad Cop earlier doing some competition, looked fun. Bad Cop was streaming today? Really? Bad Cop. Is white space is to have character, we return boolean. Advent of code in bash. Again? I was doing it while I was sleeping. All right. Okay, so we just say, for now I just say C is equal to space. Do I even have ors currently? I'm not sure. Or C is equal to /n. I don't have this, right? There is no core syntax or. Yeah. So we just do spaces for now. That's fine. Do you even have or? No, I have the syntax for it, but I don't have the implementation for the syntax, right? It's fine. We can add the or easily. Can I find the type boolean in scope? That's weird. Do I really not have the that stuff in the prelude either? Let's go to common and say that use std boolean. This should be in the prelude, I guess. Okay, so for now, just C is equal to a space. That's going to be good enough, right? So now we go over the characters. Person does class have monads? Could we? Well, I have the syntax for this, not the implementation. Huh? I don't have booleans. We have booleans. I didn't have it in the prelude because it's not like the bool is not like the keyword, right? It's a name that exists in the standard library and it was not imported basically. Okay, I and C. Actually, does the type system support monads already? I don't know. We can try again, I guess, maybe a little later. Let's do the advent of code first, though. I think it does. I mean, I don't have like, yeah. I think no. Well, I mean, I don't have like the type classes, right? So I cannot have it like, because yeah, we don't have type classes at all right now. But well, I mean, actually, maybe no, no, you cannot. I don't think you can. No, you need HKT for monads. Yeah, we need HKT for monads. Yes, but yeah, I think like the reason is because my generics can, like, I cannot specify the type of a generic right now. That should be the thing. And then we will have HKTs. Okay, so what do we say? Like, if character is white space C, then what? Then what? Do 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 do. It's good to watch the stream where I'm not the only one who doesn't know the language. Yeah, I mean, I barely know this language myself, I guess. It's in the process, it's not ready yet. Okay, let me implement the string trimming, right? So we just say that first non-white space is 0, right? So over here we say that if first non-white space is trim should only remove from start and the end, right? Yeah. Good morning. How do you write trim? If first non-white space, well, I mean, it can be like easily like that. So, you know, we should not iterate over the entirety of the string, right? Because if there is like a very small amount, then it should perform actually fast. So iterating over the entire string is not efficient, right? So we just do this, and then we say like while string, while get at first non-white space is white space. We do first non-white space plus equal 1, and then we also, and over here I also need an end. Okay, we need to implement an end, I think. Come on, be lazy, write a native function. No, I want it like, if I, yeah, no. We want it to, like, as much as possible to implement it in the language itself. No. But we could delegate this to, like, the interpreter, I guess, yeah. So what do I want? Oh yeah, the plus equal right now is not the syntax. Yeah, so yeah, that's fine. Let's have the syntax, and we also don't have the syntax for the while currently. I need to move this to the standard library. The syntaxes for plus equals and stuff. Unexpected semicolon over here, because while we have a do here, right? First non-one space, then it will take the space between. Then it will take the space between the sentences. Donald Duck. What? No, it should not. No, when you trim Donald Duck, you get Donald Duck back, right? So we just do this, but we need an end here because we need also while first non-one white space is less than the length of the string, and this, right? Yeah, I need that. How would you format this code, by the way? So I need the formatter to do this for me, but like, how would you format if the condition is multi-line like this? Well, it's because like this is the long name. Maybe we just rename this. If going into the std, make trim accept characters to trim, and then implement trim white space in terms of it. Yeah. Yeah. Well, I mean, should it accept characters? Should it accept a string? There is like, if we compare to the standard library like Rust, for example, which is pretty good, I guess, then it would have the trim. So it's like trim trim start on trim end, right? I mean, yeah, no, in Rust it's just like trim. Like trim by default is doing the white space because that's the most common thing that you do. But you also can do trim matches, which trims everything that matches the pattern, right? And the pattern can be a string, a character, or like anything else that implements this like trait, right? So yeah, you think that should be the name of the normal trim, and then the normal trim should be named trim whitespace instead? I feel like it's like that in all of the languages, right? I mean, I don't mind changing the names, but yeah, I don't know. It's just like the trim whitespace is the most common thing, right? Let's call trim matches, fine. And then we have a function which takes character and returns boolean, then sure, let's do that. So like it's not Charlie's white space, we just pipe it into F, right? Sure. So I need to implement end, and maybe let's just do like first. And it doesn't work because this is not a syntax, so it's not even being compiled currently. Okay, so then this would go into a single line normally, right? There we go. So we do this, and then yeah, also like length is length of string, right? And we do something similarly where last is length -1, and then while last is more than 0, and get at last is this, then we do, you know, like last minus equal 1. Yeah, allowing customization is nice. Yeah, so I would just say that trim string trim is string into trim matches string character is white space, you know, something like this. So we just need this, and then I need to return substring. I've asked from first to last minus first or something. Hold on. Let's call maybe this not first, let's call this start. And this we will call end. End is exclusive. That's how you do it normally, right? So while end is more than not more than even 0, right? Well, end is more than start, I guess. Would make sense. And then we get end as end -1 then, right? Then we subtract 1 here. There we go. And that should work. So now the only... Yeah. And then like if the entire string is white space, this is going to be equal to length, and we will return the substring from end to end, which is going to be like 0. I think that should be fine. So I need to implement the end. Okay, let's work on the language. Improve the language. Okay, we implement end and or, I guess. That's what we need. Let's open the language now. That should be really easy though. But the and or, the thing about those, they should be... they are not just... what about fixing LSP? I think I will do it after like solving at least the part 1. But yeah, I should fix the LSP too. I need to like figure out why it's happening. Maybe it's actually like very easy. Like I just don't understand why is it breaking. Let's see, LSP processing. This is what we want. So when I recalculate global workspaces, process workspace. Let's see, process workspace is just doing cast interpreter. Cast interpreter default. Evaluated. Compiled. Oh yeah, this is me figuring out what are the workspace roots. Yeah, this is processing the workspace file. And then we go for all the workspace roots. We process file, global state. This. Okay, so what is process file? And what is my global state? It has import cache. Maybe I need to like clear my import cache here. Process file. So we parse, parser works just like that, yes, and then we should just compile, compile, import cache default. Oh yeah, oh wait, it's because it's using compiler default. Compiler, oh wait, compiler is compiler default. Default is a function which creates the default compiler. Yeah. No, wait, hold on. I should have like the new compiler every time. So it's just because I have the import cache here. I think I need to clear the import cache is the only thing. Before I process the file here. Probably. That means that I will need to like recalculate the entire of STD though on every yeah, that's why I was not doing it, right? Because we don't want the standard library to be recalculated every time. But because I don't recalculate it every time, like I'm messing with its types currently. Like what I should be doing is that the things that are imported are not mutable. But they are mutable right now. Global import cache compiler and it import cache. We just like clear it, right? But we should say here that to do make imports immutable and stuff, you know. Actually, like it is an interesting question. Do we want that or do we not, right? So let's so right now I allow inferring the types from everywhere, right? But if I import a library, when you write a library, usually what you do is you want to annotate it with the types. Like you can, yeah, you know. But when you're working on your own project, maybe you want to use the type inference, you know, like a global type inference. But it's probably like not a very good idea to do that in your project anyway. But like, you know, maybe some people like that. But like in OCaml, for example, if something cannot be inferred, it will complain about it. Like if something cannot be inferred in a module, it will complain about it. Rust doesn't allow not specifying the types on your functions anyway. So yeah. What happens in Haskell? Boom, 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 boom. What happens in Haskell? String crashes. DC crash? It froze. It froze. Maybe it's because of my LSP again. Maybe it's once again I used like, I don't know. There's something wrong. And it broke my camera, by the way. Let me plug it. This is weird. Like it crashes and then also my camera is like breaking, so I need to like unplug it and plug it back in. Weird. I need to like maybe I need to like limit my my LSP. It's because I did not limit it in my Advent of Code repository. I only limited it in my when working on the language itself. Yeah, I have a memory leak. CastFMT is confusing. You can feel free to rewrite it from scratch if you want, but it should work, right? It's the most important part. But what's confusing there? Oh my god, implement and or, let's go. Um, clear, import, cache, and actually, wait, no, I understand what I need to do. I need to clear it not here. I need to clear it before... Yeah, because I still want it to be shared between all of the workspace roots. Yes. Process workspace. Initialize workspace. Process workspace. Yeah, process workspace, I think. Over here. Just need to check the spans of white space parts. If they exceed one line, print an extra line. I mean, maybe like every. I think I would do it like very easily, right? So we're just printing token by token, right? Isn't there something like print? Let me see. Cast FMT. It should be like really easy. Like every time. Yeah, it's like it's really short too, right? Yeah, over here, just print the thing. And this is our original span, I think, right? I'm not sure. Yeah, I think you are always printing with the original span. So this over here is the original span. And then you have the previous span. And so if the previous span and the new... So if the previous thing that we printed ended on the... like at least 2 lines before, then we print the new line. Yeah, I think that should be easy. You built an entire Nix project for no reason. I know what you mean. Oh yeah, anyway. Clear import cache.
Hello Dev 9 inch nails ya.
Hello Dev 9 inch nails. Clear import cache when processing workspace in LSP. Okay, yeah, let's do that. I think that should fix it. And then what I was doing? I was doing the ors and ends. Yes. Core syntax. Yeah, and like I'm saying that the and or should be not just a function, because these operators are like lazy. They only evaluate the second argument if it's needed to be evaluated, right? And because of that, it should be a part of the expression, right? So we need to go to types right now. And I need to add expression. I need to add expression and an expression or. Okay, so I need to add those things. Right? They must be an expression, right? I think. I think so, right? Yeah. Expression and the expression or. Expression and left hand side expression and right hand side expression. Sishumara, hello. Thank you for the raid. How are you doing? Are you doing Advent of Code? Oh, you are the SAD. The one who solves Advent of Code in SED. How's it going? Did you solve at least one day? Yes? Did you solve one day already? Alright, I'm here trying to solve the advent of code in my own language, but right now I realize that I want to have ands and ors, and I did not have that before. So I'm going to really quickly implement like these Boolean expressions, right? And then we will go back to the actual advent of code. Hello, Camimoop. So yeah, my language is written in OCaml, so I'm writing OCaml right now. We have expression and is left hand side and right hand side. Expression or is this. There you go. And then I need to duplicate shit because, you know, because OCaml makes me copy paste my code sometimes. Almost 2 days now too, but my code is incredibly slow because SED has text manipulation by regex. Yeah, that makes sense. My language is also not super fast because my language currently is interpreted. It's not compiled yet. So the interpreter is relatively slow currently. I need to like see if I can maybe improve the performance somewhere. Okay, this is the printing. Expression and left hand side, right hand side. This should be and left hand side is this and right hand side is that. Print exploration left hand side. Print expression right hand side. And we do the same for the or. There you go. I solved day one using my language yesterday entirely inside Twitch chat. Inside Twitch chat. It's a fully programmable bot, but anyone can use when it's running. I was actually thinking that I should do that too. Like, you know, you would like do something like this, you know, cast 2+2, and then it will like run this as like the code evaluated and like, you know, run the code that you put in chat. And then we will have like some chat specific things. Yeah, we probably should not expose removing the root, but you know. There's reverse representation though, so it intimidates most people. Yeah. I'm trying to make like an actual programming language. So I'm trying to actually, yeah, it's, you know, I'm not like doing these masochistic things like trying to solve advanced code in SED or use a language that is Polish notation. Yeah. I can see how this is fun, but that's not what I'm doing. Here's my day one code, for example. Let's see. Oh, like it's like the interpreter, and it's like yeah, yeah, okay, yeah, that makes sense. Yeah, yeah. I mean, I guess like since I have a REPL, we can do like the same stuff, right? Not here, I guess. Yeah, I mean, like it's just a REPL, and you just put this into like the thing. Yeah, it's easy to do that. Nice. Reverse presentation is just a syntax. It does not even make the challenges harder. Well, I mean, yeah, I guess. Yeah, that's true. Check mine too. So you should, yeah, let's see. The SCD one. This one is going to be even. This one is going to be cursed. It's like 1,000 lines of code. Yeah. Beautiful. Does SCD have includes? Can you like, or do you have to write everything in one file? I guess you have to, right? So like some of this is actually your standard library. Mathlib, there we go. That's how you do the multiplication. Beautiful. Yeah, I don't want to do that. but it's nice that someone else is doing that, I guess. No, what no? Oh, what? Oh, no includes? Oh, okay. Yeah. All right, we are implementing ands and ors. Print expression short. Yes, let's do that here. Expression and expression or. Okay, and then in the interpreter, when we try to evaluate expression and to be near the if, I guess. Expression and left-hand side, right-hand side, right? So with the way we evaluate this is we only evaluate the left-hand side and right-hand side only if the left-hand side is true, right? So left-hand side is evaluate left-hand side and then value expect Boolean, I guess, right? Yeah, and then we go into match that with none. Then we go error. We say that error. Let's as data span. Left hand side of end evaluated not to a Boolean. Okay, if it was now if it is actually some left hand side, then if left yeah, let's actually do this is if it is some true and if it is some false, right? If it is false, then we just return immediately the false, right? So we just say value Boolean false like that. And if it's true, then we need to evaluate the right hand side. So we are going to say match eval right hand side, expect Boolean there. So if this is none, and we also return the error, but in this case we say that it's right hand side. If it is some right hand side, then I return Boolean, which is literally just this right hand side, I guess. Like so. And this is a right hand side of and evaluated not to a Boolean. Okay, there we go. And then we do the same for the or. But for the or, we say that if left hand side is false, only then we evaluate the right hand side and return the right hand side as is. And if it is true, then we just return the true immediately, right? There we go. I mean, technically, I could have implemented this not as a built-in syntax, but like, I guess this could be like a macro or something. It's fine. We'll have it built in for now. Evaluate state, right-hand side. Okay, so now we go to this is the initialization. This is for the type inference. If I have expression, if left-hand side and right-hand side, then we need to say that that left-hand side type must be inferred as a boolean, and we return boolean. So both left-hand side and right-hand side must be booleans, and we do that. And we do literally the same for the this is for and for ors. Okay. And now this is just going to be a to-do, I guess. And the LSP inner compiled. We have expression if or not if, and or expression or. Then we say handle expression left hand side, handle right hand side. Okay, nice. So this should make me no, it's not it. We need to also have the core syntax, I guess, for the like and for ors. Right. This one should be the simple one. Let's see. So and something here like that. So and must be expression, yes. We will have expression end where left hand side, so I need to like say left hand side, and right hand side is children tuple unwrap unnamed 2. Tuple map child expect AST. Is that what I do? So these are the two AST. So left hand side is compile the left hand side in the same state, right? And right hand side is compile right hand side. Initialize. Okay, that's it. That should be all of it. We do an OR here. Similarly. Okay, let's try this. Let's go into maybe the REPL here. Okay, no rule. Rule failed. No such file or directory. Types ppml. What do you mean? The OCaml is like breaking for me now all the time. With a different error every time too. OCaml dep returned unexpected output. Like what? This time it actually works. So now I need to like the compiler to be invoked like 1,000 times, otherwise it doesn't work. Okay, let's see here. So yeah, true and false. This is going to be false, true, and true is true, right? Yeah, so we can do something like this, right? Print, let's do use std prelude star, right? So we say like print 1 and true, or print 2 and false, right? So this should only print 1, and that's what it does, right? Because it's already true, so we don't actually evaluate the right hand side. Time to rewrite the OCaml part to a real language. Yeah. Okay, I think this is implemented the ORs, and ORs. Let's just try using this now. But yeah, also, why did my stream crash? I have a feeling that it's happening because of my LSP. So what I'm doing here is I am doing systemd run with giving it maximum memory of 1 GB. Because I was leaking memory in my LSP, right? So let's do this also, but I'm not doing it like in my actual thing, you know. So I want it to be limited. Yeah, I want this to be limited. Did LSP solve my RAM again? It might have happened, yes. Maybe I like should watch my RAM all the time or something. Why is boolean not implemented as const bool type true and false? I don't know, maybe. At some point we should do that. There was a reason for that. I don't remember what the reason is. Well, I mean, yeah, we should like at some point we should look. Maybe it's because like of the way we are implementing the language, right? Because I implemented ifs before having the ADTs, I guess, right? The sum types. Yeah, and also like you write true and false. So true and false right now is I think they are like keywords currently. They are not the variable names, right? Works for Python though. Well, I mean, but for Python, it's not only capital letter; it's also the colon in the beginning because that's the variant of the sum type, which is also syntax that I need to think about if I want to change it. But even in Python, true and false are still keywords, right? But actually, are they? Python can I say true is equal to false? No, you cannot assign to true. Okay. Yeah, it's a syntax error. Yeah, because it's a keyword. Yeah. So like it still is like a little special, right? In Haskell they are an ADT. Yeah, but like then we need like a little bit of the compiler magic to glue them together. Right? Yeah. Yeah, I mean it's a good idea. It's a good idea. Like we can make the language itself smaller. Right? Like similarly to how I was just like thinking that maybe my ands and ors that I just implemented, maybe they should be implemented like not as a special expressions, but like just as a macro. Because what you could write instead of A and B, you can just say something like this. You can say like unwindable block. No. You can just say like if A, then true, else B, right? You can literally say this, I guess, right now. That's like the desugaring for end. Can we have enum variant types in cast? We already have that, I guess. Because yeah, C program lab, right? Yeah, I saw you. Hello. Is there no audio? Because like similarly to functions, the enums are all have like a single like type associated with them, which is in case of functions it's the type of the argument, and in case of the enums, the sum types, it's the type that is the type of the data that is stored with this variant, right? So it's the similar stuff, yeah. Should and be implemented like this as just a syntax sugar for this? I don't know. Maybe. Anyway, let's go back to the advent of code. So I need to update my language. Let's watch my RAM. Nix is working. I want to take a look at this a little later, I guess. Okay. So the language server is going to restart, and we have the ends, and this is working. This is a boolean now. Nice. Okay, so this is properly parsed. Now what do we think? String split once, like that, right? And this works. Nice. And then we also want to say that start is start string trim, right? And end is end string trim, right? That's how we do it. So now we have parsed the input of the day 2. Wait, it doesn't work. It doesn't work because the /n is the thing that needs to be trimmed. So is white space is this, or it is a /n, right? Or it is a \t. Do I have \t's? I don't know. Let's see. Wait, unexpected or? Oh, wait, I cannot have like... Oh, it's not associative, right? Yeah, okay. I need to like fix that, I guess. That is really easy to fix though. Here's my syntax. For and or. So this so and has higher priority than the or, right? Hello Proxy, thank you for the raid. Proxy. Did you solve advent of code? I just finished the second day. Yeah, I'm like kind of just starting, right? I softly oppose associativity, wrote a whole manifesto about. Wait, are you saying that and or should not be associative at all? What about the priorities? Maybe their priorities also should be the same, but they should not be associative. So you cannot say like, are you saying that it should not be possible to write like this at all? You wrote a whole manifesto about it. Can you link it? Languages should just always require parentheses. What about like 2 plus 2 plus 2? This also should require parentheses. Are you a Lisp enjoyer? I don't know. I feel like for this, no, I think I want associativity, but it would be interesting to understand your arguments. But it is left associative, right? It's supposed to be left associative, and is also supposed to be left associative. Left associative, and or. Why do most languages have a complete operator precedence? How do you turn the night mode here on? Anyway, C has a famously confusing operator precedence order. It is divided into 15 levels, and within the levels there is a clearly defined associativity. Most programmers don't fully remember the exact precedence rules when writing code. So to aid understandability, style guides usually recommend any extra parentheses, even when not required by the compiler. Most languages do the same. Python has a complete stuff. In all these languages, the exact rules are complex, and people don't really know about them and just use parentheses, both for ease of writing and ease of reading. It doesn't help that every language uses slightly different rules, further adding to the confusion, especially when they are otherwise syntactically similar. My question is basically, why do languages? No, you must do it the Java way, call.add. Yeah. I mean, Java way is different between like the native integers and the custom integers, I guess. My question is basically, why do languages, including modern ones, bother to explicitly define the associativity for each operator instead of just erroring in cases more complex than PEMDAS? What is PEMDAS? In some cases, the precedence and sensitivity is obvious, but often it is not, and I don't understand why languages make arbitrary decisions in those cases. Yeah. Well, I mean, what about like if this is not obvious? Okay, sure, it is not obvious, right? So, but another thing that is not obvious is that A and B is the lazy operator, right? Or like, because it only evaluates B if A is true, right? That's another thing that is not obvious, and because of that, it should like it should be something else, right? Like this operator should not exist at all. The PEMDAS is this: parentheses, exponents, multiplication, division, addition, subtraction. Yeah, but I think ands and ors are kind of like in this category. Short circuit comes up enough that you remember it. The exact order of operations does not come up that much. Often code with incorrect order operations will not work 75% of the time. But you are saying that this is outside of this. So what's the example outside of that, though? What are the operators outside of PEMDAS? Like, for example, in my language, the semicolon also is an operator. So technically, when you say f part semicolon this, it also technically, like, this over here is in parentheses. Should this be explicit? I don't know. That seems weird too, right? How's my RAM looking? Looking good so far. 2 divided by 3, 4 plus 2. But I can see how your, how also, like right now in my syntax of my language, we have functions which can be called without parentheses. I can see how it can, like, be a little bit weird sometimes, though. And I might at some point change the syntax to require parentheses for calling functions. We'll see, though. In C++, comma is an operator, yeah. The obviousness is open to debate, but I think languages need to be faster to require parentheses. It's now deprecated? Really? C++ deprecated something? No way. Just kidding? Oh, okay. Right. Let's see what's happening here. Unexpected OR. Did I push this? Yeah, I need to do another Nix Flake update. All right, we're still parsing the input of the day 2 of the Advent of Code, by the way. I should have moved these things to the standard library, by the way, while I was at it. You know, the whiles and subs and, like, operators with assigning. Nope. This. There we go. So now we have parsed this thing properly, right? And we have trimmed it and everything. Okay, nice. Let's actually solve the thing. So now we just need to what? So we have start and end, and we need to count the amount of what was the thing again? We need to count the amount of invalid IDs, right? All right. And it's going to take infinite amount of time, or are the ranges, like, small? I think in the actual input, the ranges are going to be huge, right? Let me get my actual input. Day 2. Wait, this is actually a very small input, right? This is very small. Day 2 input txt. Let's see. You know what we should do? We should, like, print the length of each thing, right? So let's say that's start. So we trim, and then we do string to int32 like this. String to int32, right? And then we say this, that, and end minus start. Let's see. Fatal error. Could not parse integer. Wait, why couldn't... Wait, is this not an integer? This is bigger than an int32. I need int64s. Shit. For the Advent of Code. Okay. It's more than 2 billion. That makes sense. I failed parsing because of that. Okay, implement int64. Let's go. How's my RAM looking? Still less than 10 gigs. Okay. All right. Implement int64. Let's see. stdlib over here. Let's see this. Just say native int64 is that. I will need to do yeah, and then I will need like int64 to string. I don't. I mean, converting to a string, yeah, converting to a string would not be possible. Like I don't have string operations yet, so I will have to make this be available in the interpreter for now too. Cast without 64-bit support. Well, now it's going to have the 64-bit support, I guess. I don't have floats right now also. I don't know if we will need that in the advent of code at some point. We probably will, right? Let's see. I need to go to types. T type is type shape. Type int64. And we have value int64. Hello, can you please talk a little bit about the pipe in your language? Is it used for calling functions? Yes, with first argument matching type on the left. Right now, it's not the first argument. It's literally like my functions only have a single argument for them. So it's literally, it just, instead of calling function argument, you can just say argument function, right? It's not about the first argument, because my functions are always single argument. Yeah. That's all. And yes, I forgot to duplicate my efforts. My bad. Yeah, and actually type here. Okay, do you like this now? No. What do you not like? Signature mismatch. Value shape is not included. V in 64. Oh, I did over somewhere in 64 of int 32. Can you read chat, please? Why is there no audio? Did you hear the TTS? Make int 128 just in case. I don't think OCaml has int 128. Yeah, OCaml only has int 64. I think big integers are also not part of the language. Yeah, OCaml doesn't have those, so yeah, whatever. No 8 or 16 either. I don't need them yet. I want to make the I want to keep the language as small as possible for now. You know, so I will just only add things when I need them.
TTS.
Yeah, I hear the TTS now. Print. Type in 64 in 64. Value all. Oh, no. Should be int 64 to string. Type of an int64 is int64. Int for value shape t int64 none. For inference, We do that. And then it is the inference for types. Those was for values. Okay, substitute bindings. Int64 is not substituted. Value int64 is also not substituted. LSP completion, if we have the int64, show the variable icon when I'm transpiling to a camel. Let's just, I just ignore the camel transpiler for now. Okay, nice. Oh my god, I hate this. No native int64. Like the OCaml compiler is just like breaking now. Is it, maybe it's because I'm not using the like whatever, like I'm not locking my build library and that's why it's breaking. But if I don't lock it, like here's what I'm doing, right? I'm doing Dune build watch, and then somewhere I'm also saying that it should not lock my build. Maybe it's in Flake. Yeah, Dune config global lock is disabled. Like maybe this is breaking it or something. But it would be a pain to do that if I re-enable the lock. Do you look for 127? Oh, you mean like in OCaml? Because the integers by default are not 32 but not 64 but 63 bit, right? Okay, so we yeah, now I need in the interpreter natives say that we have the type int64 corresponds to this, and then we need to say string to int32 and string to int64. And I mean, and the other way around. Should also be available. All right, let's see. So now if I try to say, so, but still 1 to 3 is 1 to 3. Yeah. How do I do it? Then I also need to be able to convert the integer 32 into an int 64, which I cannot do yet, right? Yeah, but I can do like 1 to 3. Let's see, 1 2 3 1 2 3 1 2 3, so like 5 billion or something, right? 5 billion into string to int32 is something that cannot be parsed, but if I do that, RL wrap is broken, to an int64, then that is going to work, right? Yes. Okay, but yeah, I think I need to like at least add the conversion functions. And later I will also need to like infer the integer type properly. Like right now my literals are always an int64. Let's see, we need to have like int32 to int64. And the other way around. String parse int64 int32 to string. Actually, you know what? That's exactly what I'm going to do for now. It's fine. I agree with that. That's a good solution. But what about addition? Hold on. I need to have like operators then too, right? I need to like have the operators working too, which is like annoying a little bit. Hold on a second. What is in my standard library? The operator minus even, like, right? Let me take a look. Standard operator, right? Yeah, the operators only work for int32s currently. So these things also must be generic. Okay, let's fix that. So the operators should be the generic things that work for all t's, right? Like that. And then the implementation should be generic too. This also, okay, but whatever. I'm not worrying about the transpiler. Oh my god. So we have the binary operator, and then because OCaml cannot have like generic polymorphic stuff, I will need to give it this dedicated implementation for int32, and I will need to give it the dedicated implementation for int64, right? All right. Hello, GK Alvins. Kelvins. Hi. Expect int32. Yeah, so like the implementations here should also be different, right? Yeah, I guess I need to like match a value and b. Right? So if they are both int32s, then we can do the value int32 of int32ab, right? Let result be this. If they are both int 64, then we apply the implementation for that. I guess I can also do the strings at this point too, so that way we can do the string concatenation finally, which I did not have before. No, that's only for plus, right? But the other operators don't really matter, right? But we can say only for plus. Like for now, I guess like string minus string is also concatenation. Only for plus. Okay, that's okay though. Type classes when? Like maybe soon, I don't know. Otherwise we return. Okay, and then we say result. There you go. Unbound constructor. Can I say that this is value shape? And you know the constructor, thank you. Hello, your inti. Okay, so we have the binary operator plus. This is going to be int32 add. And it's going to be int64 add. Int32 sub, int64 sub, int32 mul, int64 mul. Int32 div, int64 div. Okay. Let's see if this is going to work. On my stream randomly. Welcome. Welcome. How are you doing? What were you looking for? For someone who is solving adventive code or for someone who's making a programming language? I'm doing both here. Same time. We are soon going to actually solve the part 1, I think. But right now I'm adding the int64s. Let's see if I have one into string 2 int64. Oh my god, the fact that RL wrap doesn't work right now is a little annoying. The reason it doesn't work though is because I was like, I'm recording everything that goes in and out of the thing because I was debugging my LSP. Remember how I was like trying to debalance my LSP? The reason is because, of course, the library that I was using was wrong. I fixed it, but maybe I don't need this anymore. Let me undo this. Like if I don't use the T here, that's going to be better. Let me just comment that, and then just do the systemd run, like so. So just limit the memory and just have an RL wrap. Okay. Found you when I was looking for someone who's making a cool puzzle game. Yeah, we're also making games here sometimes. Okay, now we actually have the RL wrap working. Okay, nice. So we can do one. A is 1. String 2 int 64. And then we have a B, which is 2, right? And then we have A plus B, which is 3. Okay, nice. And then if I say like let C be equal to 3, and then I say like A plus C, then we have inference error because we can only add the same types together, right? So that makes sense. Okay. Make RL wrap work again. No need to save log anymore. And this is going to be in 64. Okay, let's also move like the other things to the standard library that I wanted. I think this string stuff can be moved to the standard library, so let's do that. String can have these things. Can have these as const if I want to use them at compile time, I guess. But I don't think I will need to, but let's do that anyway. So we do that, and yeah, also I don't have the char, so I will need the char include char char is just that. Someone who shares the same level of curiosity. I'm currently making a RISC-V native operating system where everything is an object, even files, and there is no lineage glibc. It's purely implementation from scratch, zero legacy code for compatibility. Nice. Nice. I'm not doing a lot of low-level work. I'm trying to focus on the high-level stuff, but the language that I'm making is supposed to allow for low-level code too, like similarly to how Rust is both low-level and high-level. But for now, we just focus on the high-level part. Okay, so this is just me improving the standard library like string and char. Take a look at RAM. RAM is under control. Okay. And then syntax. Add a sign, sub a sign, while. Let's do that. Yes, let's do that. Let's have the syntaxes. And I guess I will do the other operators too then. Let's do the other operators too. Let me just commit this. String, extend, string, and char module. Let's see if this works. Wait, hold on. It doesn't work. Wait, why does this not work? Oh, it doesn't work because I don't have a while. I'm using while here. I'm using plus equal, and it doesn't work. That makes sense. Because that needs to be done after, not before I implement the syntax. Rules of the syntax. Let's see. Add assign, sub-assign. Where does this go? 15. 15. Wait, why is the priority 15 actually? That's not the priority that should be, right? The priority of plus equals should be the same, the priority of an equal, right? Yeah. It's like over here near the assigns and stuff. So the priority of 2, literally the same priority as the equal sign, right? So we do plus equal, minus equal, star equal, and then like divide equal. What else? I guess that's all that I have for now. And then the while should be at the 7.5, similar to match. Yeah, that makes sense. When GCC output files and I want to use that. Everything is an object, even files. GCC outputs files. Well, I mean, should just, I don't know. I don't know what it means. Everything is a file. Everything is an object. But I heard that like this thing where everything like, so like Linux does everything is a file, and then there was like this other thing where everything is like an API or something like that. That was interesting, but I don't remember the name. Sounds like you invented PowerShell. Everything is an object in PowerShell. And NAB summation from A to B. Do you want me to introduce the syntax or summation from A to B? Any more languages that use this symbol? No, I think I should only use the ASCII. Okay, now we implement the syntax. Syntax over here. We implement this minus star and divide. This is not the correct implementation, by the way, but it's good enough for now. And then we implement the while. And then what else? What else can I implement? Maybe that's good enough. Okay, so let's see, you know, let x be 1, x plus equal 100, x at 101. Okay, so that works. While false, do nothing, and that's exiting immediately, while true, and we do infinite loop. Okay, now, nice, that works. Okay. Op equal and while. That works. Anything else I wanted to move from here? Let's include common. Yeah, extend the standard the prelude, I guess. So in the prelude, I need to yeah, I guess we use int 64 to string, and I use int64 itself, and I use a boolean, and I use a character, right? Like so. And also the module string and the module char. Use string, use char. IO print, IO input, dbg, collections list. Yeah, I think that be better. Cast. Input to. Oh yeah, I think also like in the REPL, the prelude should be automatically imported. Okay. Okay, go back to this thing. So I should be able to like remove this now. I should be able to remove the syntaxes from the day 1 too, by the way. That's unnecessary now. Okay. Update. More string and char, we don't need this anymore, right? This moved to standard library. So this is the entire thing that we have left. As soon as this updates. Someone will definitely make a mathlib forecast with all the symbols. Are you talking about yourself? I mean, you can, yeah, you can. Just use the library for sure. I mean, actually, you cannot yet. I actually don't have the ability to import syntaxes from other files yet. But other than that, would not parse int 32. Okay, so this is an int 64 now, right? Okay, there you go. So let's see. This one is 10 to the power of 6, a 5 actually. This. I guess you can like iterate over all the numbers in the ranges, right? All the ranges are small, it seems, but it's probably going to be like really slow in my language, in the interpreter currently, right? To iterate over 100,000 of things. I'm not sure. But yeah, let's actually write the solution. It should work at least for the example, right? We go over the thing and we check. Well, I mean, yeah, what we need to do is... What? Yeah, let's actually do the correct solution immediately, right? So we go... Well, I literally just remove the first half, right? I literally just remove the first half of the number, right? Boom, 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 boom. Ding, 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 ding. Need to play with the context systems to see how it changes the code. Yeah, but I don't have the inference yet for that. It's dynamically done currently. I'm not even using it. I mean, I'm using it just a little bit currently. Let's see. What do I need? What do I want, right? I think I want to... Actually, we just... I think we do something like this, you know? We say that we start at the start, right? And then we say while true, just loop. What's wrong right now? Unexpected. Oh yeah, I cannot do empty loops currently. That makes sense. I need basically to say actually int64 to string x, right? So x as a string is this. I mean, in the end, we will say that x plus equal x plus equal 1, which is this string to int64, because that's the only way to do it currently. Then I want to ping, 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 ping. No, that's not even what I want to do, right? What do I want to do? I want to like split this start in half automatically, right? Yeah, we want something like this. Hold on. Let start I don't know. Hold on. We do int64 to string back. Int64 to string. But I need to take the right half of this. So I do string substring of s starting from length of s divided by 2. Is this what I want? Yeah, the LSP right now is kind of slow because it needs to parse the standard library every time. But at least it doesn't do the... it doesn't break. I don't need to restart it. But okay. So yeah, that's what we want. So this is string. No, I want, and then I want this to be done into string to int64 back. So we take the half of the thing. Is adding if span start line and this after this in this the entire fix? Probably. I don't know. Can you try it? You can try it, right? Does it work right now? Try formatting some files in the standard library and putting some empty lines there. So if it works, then yeah, just submit a pull request and we'll just merge it, I suppose. The entire standard lib is unaffected. Yeah, nice. Maybe you can also like introduce some empty lines in the standard library if you want. I don't mind. Even whether that would make sense. So we have the starting thing. Wait, why is it this inferred to be a string? Why is this a string? String to int64, string into string. That's wrong. What if I restart the language server? Now it's int64. Oh shit, it's not fixed yet. Okay, so I still have like some weird stuff going on. Okay. Deal with my types when I'm writing code. Okay. So we just add one, right? Let's call this one. To do language. Wait, can you also? I thought this was. Yeah, I cannot have the the comment after the end of line, right? Right now in the formatter, it prints the space over here. You can also look at that, maybe in a separate pull request, if you want to improve the formatter. Plus equal 1. But when do I break, right? So I break when the number plus itself, what? The comments after the end of line, you know? Comment after end. This is right now, the formatter puts this on a separate line like this. Right? That's another thing that could be fixed. So I think I break when, so like combined is going to be x string int64 to string x plus int64 to string x, which probably should only be done once. Performance. So we just concatenate the strings now. This is combined. Yeah, and this is the combined number, and we just do that into string to int64, right? That does not work. We need this. Then I say that if combined is more than end, then break. Right? If combined is less. Oh wait, I think I did not implement the comparison operators for int64s. Because my RAM is going up, by the way, slowly. Is that used by cast? Yes, cast is using 23% RAM. Yeah, I'm leaking memory. Still. LSP has a leak. Yeah. Like, it's like, maybe it somehow is still saving everything from the previous versions of the code or something. I'm not sure. It's not OCaml itself that has a leak, is it? I hope not. Let's run on the example first. 7. Is 7 the correct number for the example? Oh, wait, we need to add up all the invalid IDs, right? Yeah. So I need to add to the answer the ID itself. Which is the combined. That is the ID. Type check failed. Because answer is not 0. It should be 0 string to in64. One two two 777 4544. Wait, 4544. But I need 4554. This is not correct. Let's see. DBG print combined. Let's see all of the invalid IDs. The first one is literally not working. Why not? Let's equal 1. Is combine is more than end. Then do this. Like, I started with 1, then I added 2, right? And then we say 2, 2. And so 2, 2 is not more than end, is it? Let's print the combined over here. DBG print. Good. Something like that. I think it's not only leaking memory, I think it's actually lower over time, the LSP, but I'm not sure. I just freed like 8 gigabytes of memory by restarting my LSP. Nice. That's how you garbage collect, yeah. um Am I checking this many things? Example. Let me just try 1122. Test txt 1122. Test txt 11 good, 22 is good. Okay. So shouldn't the answer DBG print combined? Yeah, edit those together, it becomes 33. Okay. Oh wait, no, 1122. Wait, what? It wasn't saying 22 earlier, right? So yeah, we have 1122, we have 99. Then we have yeah, I am missing 1010. How am I missing 1010? So it's because I am starting by so like what I'm doing is I'm splitting this in half. And I'm starting by 98 here because of that. But that is not correct. That's too big to number to start with, right? I need to start with actually like yeah. I need to like replace all of the things with zeros. and have like the smallest number with this many digits, right? Which is going to be 10. Or is that too much? Hmm. So like this start should be this the number with the amount of digits equal to the string length divided by 2 rounded up, right? So we do say length is string length s plus 1 divided by 2. So then I say that we can create a new string. We start with 1, then we say that while length is more than 0, length minus equal 1, s plus equals 0. And then we convert that to to the thing, to int64. String length string length of int64 to string start, right? That's what we want. Ten. Wait, no. While length is more than 1. This is how many digits we want. There we go. Okay, now the answer is correct. For the example, at least. Alright. And even for the example, it still is thinking for a while. So what if we do actual input? I really want to like at least yeah, let's do this. And then I'm also printing the numbers. Not test, the input txt, right? Let's see. It's a little slow, but you know, it's making progress. So we still are iterating over the ranges of 100,000 length. Yeah, but like technically this should take just like less than a second, the entire thing. Let's see if this is the correct answer. It is the correct answer. All right. Why is it that slow? I need to like look into where my performance actually is, like try to profile the thing. Okay, but part 1 is solved. Beautiful. Part 1, day 2, part 1. Nice. What is next? Let's see how much more difficult is the part 2 The clerk quickly discovers that there are still invalid IDs in the ranges of your list. Maybe your the young elf was doing other silly patterns as well. Now an ID is invalid if it is made only of some sequence of digits repeated at least twice. So this 2 times, this 3 times, this 5 times, and this 7 times are all invalid IDs. From the same example as before. Okay, that is easy actually. That is easy. So so the amount of times that the thing can appear, right, is at least 2, and at most the length of start, right? So yeah, and then we will do it like multiple times here for all of those. That should be easy. So we say, so the amount of times that we try is 2, and we say that maximum times is if we are solving part 1, then is also just 2, but otherwise the maximum times is the length, right, of the start. Wait, not the length of the start, the length of the end, actually. End into in64 to string into string length. Something like this. Okay. So now we say that while times is less than or equal than max times, we do something. I cannot figure out how you're parsing, so I cannot do this. We'll try tomorrow. Okay. Did you do the pull request for the formatter of the empty lines? What's my repository? This one. Oh wait, that's not the repository even. You did not do the pull request for the empty line. Hello, farmer. Hi. How are you doing? Okay, so we do that. Can I format? Thank you. So over here in the end, I will just do times plus equal 1, right? And over here, so I'm going to over here, yeah. So now we are going to divide by times and round the things up. Times minus 1. That's how you divide rounding up. And then we do that. Yes. Nice. And then we go like so, and then we combine. Yeah, so say combined s is an empty line, right? And then like I need a new thing. I need a 4 like let's do a simple loop, a 4 range, right? From 0 to times. That would be really nice. You know? If I had that. That could be a simple syntax sugar. Let's implement this right now. So we have a syntax for range. This is going to be something 7.5 like while, I suppose. Wrap. Okay, so it's going to be for pattern. For pattern. For pattern in start dot end do body, right? And then we implement syntax for pattern in start to end. As we say, let pattern be start while I guess maybe it should not be pattern or something. Well, I mean technically, yeah, whatever. We just do a while pattern. Yeah, I mean this should be on the outside. It should not be visible outside of the loop or whatever. While pattern is less than and do body. Yeah, I guess we can do that. And over here, then this is also is going to be similar. This over here is going to be 4 times in 2 max times plus 1 then. Right? Because this one is exclusive. We need like an exclusive one, an inclusive one too then, right? Which is separate. Do I do it similarly to Rust? Dot equal? Is that a ligature? I don't know. Do we want that? Until it's equal? Let's do just that for now. Unexpected closing bracket. Yeah, because I need do body. Unexpected closing bracket because it didn't save the file. Yo, Zadashore. The raid, hi. Welcome. How are you guys doing? Did you solve Advent of Code? Or something else? How's the language holding up? I solved the part 1 of the Advent of Code. We're like slowly implementing other things. Right now I'm implementing the for loop, but oh shit, I'm almost out of RAM. We need to I have a little leak in my LSP for my language, so the stream could be crashing right now. But you know, we just need to restart the LSP here. There we go. The amount of RAM that I use, I just freed 20 gigabytes. Nice. We still see you. Yeah, because I looked at it before it crashed. That's why. Let me actually like make this right now. How do I do this? That's a powerful LSP. Yeah, we have a memory leak a little bit. A small leak. Hold on. How do I do that? I want to like override this, right? My VS Code also is like freezing sometimes for some weird reason. I'm just going to say that my cast is going to be a wrapper all over this. You know. Let's see, cast is that. But I'm just going to say that this cast is going to be systemd run in a with a maximum memory of 1 gigabyte. So instead of doing exact cast, we're just going to say over here, cast. That doesn't work. This is a package, right? Do I need something like... Let's see how this works. Cast. No arl wrap, no such file. Oh yeah, yeah, and then I need to like arl wrap here too, right? Yeah, sure, let's do that. Saving Flake Nix. Wait, what? Oh, Nix IDE. Yeah, Nix packages FMT. Is what I need here too, I guess. In before temporarily script restart LSPs and every 5 minutes instead of fixing the leak. Well, I mean, I'm limiting the memory of it using systemd now. Which means that it's going to crash and then the VS Code is restarting it automatically. I cannot execute this, permission denied. Yeah, because like I need to do... This is just a path, right? And I need to do like bin cast. Right? That's my actual cast, yeah. Cast, bin cast, right? No, hold on. XFMT classic. That's what I use in. That's what I use, right? Skip. I'm gonna head out. Gotta do some college work. All right. Thank you for coming by. LSP's leak server protocol. Okay, nice. Now this is actually formatting my Nix too. Okay, and then we do... And now it needs to recalculate because I formatted it. Nice. Cast. Cast. No such file or directory. Oh, now I... Wait, what? Yeah, because now we don't run through the dune, so I don't need the dash dash anymore. That makes sense. We're gonna head out too. Alright, good night, Nigel. Let me just merge your PR, I guess. Should have just called this reserve empty lines in the formatter or something. But I mean, sure, yeah. Let's just merge this. I believe you. Okay, so that works. Nice. Let's try this. Unexpected do. What do you mean unexpected do? 4 times in this do. 4 pattern in start to end do body. What's the problem here? That's actually weird. Unexpected do. Because that's the syntax that I introduced, right? If I do 2 to 3, does that also not work? It says still unexpected do. That's weird. I literally have defined the syntax. Right? While pattern less than and do. Let me try this. For I in 0 to 10 do that. Expected? Yeah, it's like it literally doesn't work here. Why not? Is it because the macro is expanded incorrectly? Let me just comment this. No. Oh, that does make sense. Like, it literally was parsed over here, but not there. What if I do spaces? Oh, I need to do spaces? Oh, wait. My parser right now is trying to parse the... my lexer is incorrect, I guess, right? Because my lexer thinks that, like, 0 dot... And it sees that, and it's trying to, it's just, like, merging all the dots, you know, together. Because that's part of, like, the floating point thing. I guess, yeah, I guess I can just do the... let's just do spaces around this thing for now. Right? And I'll just add space here. And add space here. That should be, like, good enough. Can I format? There we go. Now it's going to format this properly. Nice. Okay, but this obviously to do go in STD, right? That should go into the standard library. Okay. So basically, I want to do for this in 0 to times, we just do combined s plus equal xs, right? Like so. And then combined is combined s to an integer. There you go. This is not... Yeah, wait, hold on. 4 underscore. Wait, this is a pattern. Oh, wait. Oh, because it's a... Yeah. Like, I don't need this to be a variable, right? So I need to, like, actually come up with a variable name here. So, like, it actually is not the correct desugaring of the 4. So I need to actually say that let... I guess we call it, like, loop variable is equal to start, right? And then we say while loop variable is less than end, and then over here we're going to do let pattern be equal to loop variable, and then we do the body inside. There we go. Oh wait, I forgot that we need to do I forgot that we need to do loop variable plus equal 1, which also means that it also only works for integers, but that's okay, right? For the int32s. Let's check on the example first. So on the example, the answer is now... I have the incorrect answer. I have incorrect answer. Three 3859. That is still here. But now we don't count the 565656. 565653. But so it means that I never try 565656. Why not? Because, like, the times oh wait, it's because I need to do that makes sense, because I need to do part 2. So, right? Yeah, there we go. Now 565656 is also counted, and we have this thing. Yeah, that's correct. Okay, let's do part 2 on the actual input and see how long this is going to take. It's not going to be that long, right? Is it actually a heavy problem that requires a lot of computation? Have been paying attention. No, if you write this solution in C++, it will run then less than a second. And I mean, yeah, yeah, it should be like really quick. It's just I need to like actually look where my time goes. We can try profiling. It's evolving. My stream is is breaking again. Let's see. Is it actually a heavy problem that requires a lot of computation? Have been paying attention. No, if you write this solution in it's just I need to like actually look where. Yeah, I don't know. I feel like I need to undo my like thing. I think it started maybe like it started to be bad when I updated my Nix, you know? You remember when I switched to Niri, right? I went from NixOS stable to the unstable. And maybe that's what broke it. I need to like try to revert to something. Is it because of the running program? I don't think so. But like I can feel the lags also. Like my VS Code sometimes is not responding immediately. I should try something. That is not the right answer though. This is not the right answer. Could it be because like wait, hold on, how many? Like there is no way we are overflowing the int64, right? I don't even know what's the what a camel is doing when we overflow, but I don't think that's what's happening, right? Nah. One. And a bunch of zeros. And we add one. Does anyone see the problem in this solution? Did you guys solve the advent of code? So what I'm doing is I'm like starting. So I maximum times is the amount of digits in the end. That makes sense. It's not happening now. Did you stop running the program? Yeah, I mean, I did stop it. I mean, I can try running it again. Tell me it's okay, maybe. Let's see if it's going to, like, do I have the compiler mic right now? I think it's not because of that, but I mean, maybe it has something to do with it. I don't know. 1, 2, 3, 1, 2, 3. Let's wait. Let's wait. Well, I mean, yeah, maybe it's not like immediately. Like it's like maybe it's when we have the heavy program running for a while. Maybe you have to check the sub len. Is a multiple of len. What do you mean the sub len? Maybe I copied the incorrect number. Is another thing, or maybe there's actually a bug. The substring len is a multiple of the string len. What's the substring len? I mean, substring has smaller now happened, the microphone, but like my program was already not running, right? Just once though. I don't know, maybe it still is about running. Your answer is too high. Your answer is too high. My solution is basically first we basically iterate over the amount of times the subs. Oh wait, I understand now. I understand. This is actually easy. It's because I count the same number twice sometimes, right? Like because think about the number. Think about the number 11111, right? This I mean think about the number 1111. It is 11 plus 1, right? But it also is 1 plus 1 plus 1 plus 1. Okay, this is actually like obvious bug, right? I count the same number twice, and that is wrong. So I need to make sure that I don't count them multiple times. It's maybe like even more than twice sometimes. All right. So what I need is to... I guess I just store the numbers. I want a set. I want a set, which is like similar to the trip that I already have. You know? Let me take a look at my trip. I mean, how many numbers do we even have? What's the amount? It's probably not that big. You just break from the loop after you count once? No, because I'm not looping over the numbers in order, right? Because I am trying to first iterate, like, first I'm like, yeah, I'm going over how many times the substring is occurring in the string, right? So in the case of this, right, I'll try to go over all the strings that appear twice, and then I will try to go over all the strings that appear 4 times, and like so like I don't break, right? That's not correct. We just need to see if the number was previously if the number previously was or not here, you know. Let's try this. Let's do set. Let's do set. And maybe I will move that to the standard library too. I won't have type set is like the generic type. Yeah, how do I do this actually? Like, I think we will use do it using the trip. Something like that. So what do I want? I want create. I want to add. So our add is having the set of t, and I add the element t. This creates a new set, right? And then we will want to say contains. Contains is something like set x. This returns boolean. It kind of depends what I have in this set in the trips currently. How do you search for repeating patterns in those numbers? How am I splitting them? Search for repeating patterns. I don't search for repeating patterns. I'm iterating over the patterns, and then I'm seeing if I combine the patterns the certain amount of times, then it still is inside of my current range, right? So I'm not iterating all over the entire range, actually, right? But I guess technically, like, because I would need a faster language to do that, you know? So I am doing something that is supposed to be like super fast, but because of my interpreter, it's still slower than the brute force solution, I think. Let's do this simple. Let me see. I can have get add, merge, set add, split add. Yeah, split add gives me the takes the index, but I would want to split add the other thing to make, like, I could actually implement the set using a trip, so that it has like logarithmic complexity, but for this problem it probably doesn't really matter for now. So let's just say that, over here when I'm adding, this is going to be you know, it's going to be trip merge this and trip singleton x. That's all that I need to do here. And for contains, we just do trip iterate the set, and we say function element, and then we say if element is equal to x, then we I need to unwind block with true, otherwise I say false. I need this, right? So now we will be able to store the visited, you know, So visited is set create, and then over here, this is the actual number that is correct, right? I want something like if not visited, if not set contains visited combined. Yeah, but tinfoil hat theory about this task, but I don't want to backseat. Yo, Neo Ino. Hello, hello. Thank you for the raid. Welcome. How was your stream? I'm about to solve the part 2, I think. Let's see if this works. I'll try on the example again to see if it did not break. Well, but I guess it should not. Wait, it actually... Wait a second. It actually broke for the example. Your language, super cool. It was great. Just finished day 2 Advent of Code. What are you solving your Advent of Code in? This actually is not the correct answer for the example now. What did I not count? Let me try to comment this and then see if this still...
Hello Roble_SRC.
You did regex for today, and in the Neo was doing Python. Nice. I'm solving C++ for versatility. Nice. Wait, this is still the not correct answer. Wait, what? Did I just break my code? What did I do? I only created the set here, right? Didn't I have the correct answer for the example previously? The only thing that I added is the set here, right? And like this line and like this end, right? That's the only thing that I added. You should add regex to cast. The regex should be a library, should not be built-in functionality, but yeah. 41748. Wait, my number is still too big here. How is it too big? Let me see, what do we count? We'll count 212121, then we count 824 and stuff, and 5656, 389, yeah, 446, 446. Oh, 222 is done multiple times. Wait, what? 222 is done multiple times. Oh wait, yes, that's correct actually, right? It's supposed to be multiple times. Okay. I think I know the reason. I think I know the reason actually. It was never correct. My solution for the example even, right? But the reason is, I know what the reason is. Let's go to the REPL. Let's say that x is one string to int64. Cannot find string to int64. Use std prelude star. Let's do this. And then let's say that y is also this, right? So x is 1, y is 1. What about x is equal to y? True. Okay, never mind. Maybe this is correct. I thought that's the problem. Okay, what's the problem then? Let's try running again. So 222 should not... 222 is still counted multiple times. That's the problem, right? So set contains is incorrect implementation. Is this incorrect implementation? So I'm just iterating over the thing and then see if element is equal to the thing that I'm looking for. Then I just oh yeah, then I return true because like that's the thing. Yeah, hold on. The contains is not correct. Implementation. Oh, because I never added it. I'm stupid. I never added it to the set of visited things, right? I just say visited is set add visited and combined, right? There you go. That's what I need to do. So now the answer is 4174379265. Yes. Okay. And now we go for the actual input. Let's see. It's going to work for a little bit. FFI abstractions over PCRE. What's PCRE? Why is it showing me this thing in Russian? Perl compatible regular expressions. It's because like Perl's regexes are different from the other languages' regexes. Is there actually a lot of different numbers? Like, because my set contains right now is linear, but I don't think that is the performance issue right now, right? This is just iterating over 100,000. Yeah, there we go. There you go. Here's my answer. This is going to be correct. Day 2, submit. That's the right answer. Easy game. All right. Easy. So the adventive code is solved. Now maybe I should improve the language a little bit, right? It would be nice if like set is a useful like collection, right? So I should add it, and I should implement it so that it's not linear but actually like logarithmic, like it should be. But I can still base it on the trip. Day 2, part 2. Okay. Also, I kind of really want to understand where is the performance bottlenecks. My question for this day, I didn't try to solve it yet, but isn't it enough to split number in 2 and check left and right? No. Well, I mean, like what number? You have ranges, right? Like you have ranges 11 to 22. There are 11 numbers inside of that, right? Range. But yeah, if you just do the like brute force loop, that will iterate over all the numbers, and then for every number you need to like split and check the left and the right part, right? I'm not doing that because I think if I did that, my performance would be even worse than it is right now. So I need to like look into the performance. So I'm doing that more optimized solution. I'm doing like the optimized solution where I don't iterate over all the numbers, but basically, like I'm trying to iterate over less amount of numbers, you know? Yeah, something. But let's see where the performance bottleneck actually is then. You call that slow, but I'll literally use regex. Yeah, I mean, I guess if you solve it in regex, it will be slower, or like that other person who was doing it in SED, that is also probably was running a lot slower than my language, right? But let us actually profile. Let us actually profile. How do I profile? Mine in Rockstar is 100 milliseconds with regex. Part 2. Oh, I mean, yeah, yeah, I thought you said you were like you were using regex as the programming language. I'm not sure if that's even possible for this, but maybe it is. I don't know. I mean, isn't SED basically right? I guess that is what SED is, right? The SED is regex as programming language, I guess. But yeah. You think it's slow because of number formatting? No, I don't think so. I think it's my interpreter is slow. It's doing some unnecessary work in some places. Right? Like my interpreter is used to power the compile time evaluation. So it knows about things like types, and I do some stuff that is required at compilation. Even although like it's not needed at runtime, you know, something like substitution, for example, that I was doing previously. Pretty sure that's not the case right now though, but we can do profiling actually, if I remember how to do that. Let's see how to profile camel. There's a built-in thing, right? Was there assembly here? I don't need assembly. Hello? Smallest ML. The S tells the compiler to leave the assembly language. No, this is what? Why are they looking at the assembler? Just give me the profiling stuff. I did that earlier. I don't remember. This page in their docs is stupid. I don't want about assembler. Anything. Just ChatGPT. How to profile camel. Oh wait, maybe I did not know camel. Oh. Maybe I did profile Go recently. That's what I did, yeah. Go has a built-in thing. gprof. gprof style hooks. Run the program normally. A camel opt-p app your modules ML. What about Dune? How to compile this thing in Dune. Flagged -p, right? So -p is the profiling thing. Okay, yeah, that's what we want. And that's it. So we go here, we say cast bin Dune, right? So for this executable and to add flags, unknown option P. All right. Thank you, ChatGPT. Why are you lying to me? -s tells the compiler to leave the assembly language file. Fuck your assembly. What is this? Okay. Why is OCaml fast? Is OCaml fast? Why do they start the profiling with the definition of what the assembly is? Just tell me how to profile. The representation. Like, this is the description why OCaml is fast. I mean, okay, sure. But can you give me, like, some flame graph or something? Profiling tools. OCaml LCP, OCaml Prof. Like, this should be at the top of this page, not in the bottom. Get execution counts for bytecode, real profiling for native code. Perform profiling on bytecode. I think I want the native code, right? Profiling native code is done using your operating system's native support for profiling. In the case of Linux, we use gprof, it's alternative prof. We compile using the p option, your camel opt, which tells compile to improve profiling. Wait, dash p. But it's said that it's not correct, right? Unknown option p, because that's for a camel opt, not for a camel c. What's a camel opt? But p is argument to OCaml opt. OCaml c doesn't recognize it. You force Dune to use OCaml opt by building the native target. Oh, am I like actually building the bytecode? I think ChatGPT is trolling me. But the OCaml documentation is also trolling me. How to do this with Dune? Let's find Dune. There is no Dune in this page. Profiling OCaml Dune. Maybe the Google stuff. Profiling OCaml code. Landmarks. This library offers a simple way to instrument OCaml code for performance. Pre-process. Landmarks. OCaml Prof for bytecode profiling. Compile your project profiling with the dash p, capital P or lowercase p. How to do that? Profiling Dune builds. Trace file. Dune can create a trace file for its internal operations. No, I don't want to profile the Dune build itself. Anyone who knows how to profile OCaml? Why is the documentation? I mean, I don't know. It's weird that this does not. I mean, I guess Dune is like a third-party application. I don't even know how my compiler is being invoked currently. Oh, this is like an article. Performance trace with perf. There are multiple ways to know what's going on in Dune. The tool itself includes a few ways. Know that the process explained below with perf and memtrace is applicable to any OCaml, not just Dune itself. Perf is a tool coming with the Linux kernel. Perf record. Then upload this in the profiler of the Firefox. Custom version of Dune. If you want to profile some custom version of Dune. I don't want to profile the Dune itself. Profiling Dune build. Yeah, this is profiling the Dune build. No, that's not what I want. I want to profile the program originally in OCaml. How long will I stream? I'm not sure yet, but I want to maybe like look at my code a little bit, move some things into the language. So maybe like an hour more at least. Why? But hi. Maybe I at least like learn how to profile. Trying to profile. That's what I'm doing currently. Profiling OCaml programs the quick and dirty way. I like that. CPU profiling, just use perf. Dune by default includes debug symbols to the compiled executable. Oh, so I don't even need to do anything. Why does the profiling page of OCaml not tell me this? Why does it start by telling me what an assembler is? All right, just perf record this, right? Do I have perf? I guess I have perf. Okay, let's see. Perf recall. Build. Wait, is there no build? Where am I right now? Oh, this is the event of code. Yeah. I probably want over here. Build. Call graph dwarf. What does this even mean? Build. This doesn't do the auto completion. Build install default bean cast. Perf record call graph. This. And then we do cast. Can I give it the arguments here? Examples. Hello. Can I do that? Unknown call graph option. Call graph. Record mode. Call graph recording mode. FP dwarf. Oh yes, it's because I did not give it the dwarf. I don't know what this even means. Okay, so we have the, so I have profiled hello world, right? And now we just memory profiling would also be nice, right? To see where is my memory leak. If you are developing on macOS, no. How to open the thing? This thing shows a yeah, but what do I open there? Just the data file itself? That's what it generated for me, right? Profiler Firefox. Enable Firefox Profiler menu button. Like that's a built-in thing into the stuff, right? Oh no, I'm recording. No. I just recorded that thing. Profiler is recording. Don't do recording. Close it. Start recording. Settings. Firefox. Just look properly. Look where. Click load file. You mean like on the website? Load a profile from file. What file? Batchcop upside down.gif. Projects. I have too many projects. I need to delete some of them. Perf data. Could not read or parse this. Just read properly. Read this. From there, use your favorite way to view perf report. Flame graph is great. Okay. What is flame graph? Is that just a program? Is it running? Flame graph. Just give it the input file and it gives me the SVG, right? So we just do over here. Flame graph. Perf data. Perf SVG. Malform GTF8 character. Is my perf data not what I should be using? Profiling with perf. Perf recall F99 dwarf program to compile. I did not do F99. That's 99 hertz. Okay. Perf report. Oh, I need to do perf report maybe? Like after the recording, I need to do perf report, right? We first record and then we report. Over here. Okay, now we are processing and now, oh wait, but this is like this is the TUI, okay. So this is my OCaml things, right? Whatever. No. Like I just want a different front end maybe? Which would be the flame graph, right? Cannot open perf data, no such file or directory. Oh, wait. No. It's because it's over here. I keep opening the wrong VS Code. Yeah, it just says that there's like not, it's not correct UTF-8. Or something. Guide to profiling. Capture the profile. Okay, I record it. Convert. Oh, I need to convert the profile. Perf script f plus PID. Convert the perf data is something the Firefox profiler can do. Okay, what about flame graph? Oh my god. Says is the correct command for web. Perf record F99 Firefox. Profile no record. Installed Nix. You installed Nix? Going to go the one in /tmp. Okay, yes, this does open it. Well, like, why can I not have a one, like... Why is it so difficult? But okay. It's not that difficult, I guess. Classic Linux. Make this, convert to this, read magic spell. Yeah. Okay. So, okay, but let's actually run the program, right? So, so I will need to say perf. It's kind of annoying. Can I, like remembering this command is just the annoying part. Let's have it in the just file, maybe. Just profile. Right, and we have args. Is that how I do it? I don't even remember. June build. I didn't build here. Whatever. This is the one that I want. Perf record call graph dwarf cast, and this is my args, right? Let's see. Just profile examples hello, right? There we go. That's how we do it. And then we we do this, and then we do that. Perf script this into, let's do like perf like process, like I don't know. There is perf.data, and this is going to be data.perf or whatever. Perf data old. Like, what should this file be called? What am I even doing here? What does this even mean? Can I open the Firefox automatically here too, after this is done? Can this be opened automatically? I guess not, because this is not a built-in functionality in Firefox, actually. But okay. I just say in the just file here. Now open data perf. Now load this into this website, right? Okay, maybe if I have this, then I will remember. Okay, so now we want just to profile projects, Advent of Code 2025. Day source day 2 main part 2 test input txt, like only. Let's actually do it on the example, because if I mean, yeah, let's do on the actual input, right? It's pretty slow, but we'll wait for another minute, it's fine. I'll go take a bathroom break. I'm back just in time when it finishes running. and now it's converting the thing, right? We just wrote 2 gigabytes of performance data. Wait, is it even going to be uploadable to the Firefox website? I mean, it's not actually uploading anything, right? It's working in the browser, right? The profiler Firefox.com. 2 gigs, wow. Well, I mean, it was running for a while, right? And I mean, maybe, like, because I didn't give it the argument, the F99, it's not like 99 hertz, but like bigger or whatever. So like maybe I'm being a little bit too precise or something. Like, because I'm just doing this command, I don't have F99. Whatever that means. Wait, there is no dash F. Oh. Perf record. That's what I need. Perf record. Frequency. Use max to use the currently maximum allowed frequency, the value in the kernel perf. But what's the frequency used by default? Documentation doesn't tell me the default frequency. It's the value kernel perf event max sample rate. Syscontrol. How do I see this value? I'm on the wrong cast. It's data.perf, right? Wait, did it tell me? Wait, hold on. Check IO CPU overload? What does it even mean? You have problem with my CPU? Is that why my microphone is glitching sometimes? Yeah, I just did 3 gigs when converting. Like that. Couldn't read. It didn't work. I want the correct file, right? Poor potato PC. Did I open the incorrect file? Or is it because it's too big? What's the difference between that file and like the other one that was working? Perf a report. Maybe I should like figure out how to use the TUI here. Well, now it needs to process the 2 gigabytes. How to use perf report. Interactive cursed interface. Should have just profiled the example, I guess, because it was still running slowly. Check your IO CPU overload. Press any key. Here's your key. So what is this? So 70% of the time was used inside. Okay, command is cast. Shared object is main exe. I don't have any main exes. So like what does this even mean? Right? Anyway, so we have interpreter eval. So the 70% is used in the eval. And 70.93 is return with return, which is fine. What is the percentage here? This is children and self, right? I should sort by... Wait, no. Self. This is including children, and this is only self. Okay. What did I do? I pressed enter. What do I do now? Annotate. No, exit. Like, can I like not go in and see like more details, or like it's supposed to be a tree, right? Or whatever. What did I just do? I can like see the assembly here. Maybe press plus instead of enter. You think plus is the key? Oh wait, plus is the key. Yeah. Do you know how to use this thing actually? So inside of this, so yeah, this function is a wrapper around like a lot of the things, which makes sense. So we have like eval in the interpreter. So like, yeah, the interpreter is using most of the time. And then we have interpreter eval, and this doesn't have the percentages anymore. No, hold on, there is still percentages here. Eval, native function, eval. Can I like shift my screen here? I cannot even read what is inside there. How to... Okay, how to see flame graph based on a perf data. Generate perf data process for the flame graph generation. Perf script. Flame graph stack collapse out folded. Install flame graph tools. Okay, let's quit. I have flame graph. Perf script out folded. No such file or directory. What is this even? Like, how are they supposed to have this thing? Flame graph stack collapsible. Is that like... Oh, that's already like a binary? Alright. Let's see. So there's going to be the folded whatever. Like I think for my language I want to like make it very very easy. So yeah, like I actually used the Go language recently and I did the profiling. It was really easy to use. These Linux tools are a little weird. For what did I use Go? Just at work. But Go makes it like easy. Go lang profiling over here. That's the blog. Well, I mean, actually, yeah. I don't know. I didn't look at that too much. Maybe it was not that easy, but it was like just run Go with like profiling argument and that's it. This article is also like weird. I don't know. I mean, in Rust it's relatively easy if you install Cargo Flame Graph, I guess. Like I want something like that, so something that's like one command and it just opens the flame graph for me. What code am I using? C++? No, I'm not using C++. I'm using OCaml. Or, I mean, it depends what your question is about. Because for solving the advent of code, I was trying to use my language. My language is written in OCaml. And I'm trying to profile it. Okay, and now that I've done that, convert, view the profile. Wait, what? That's the other one. Quick and dirty. Maybe like I should have opened this discussion. Where's my tutorial of how to profile the perf? How to flame graph the perf? Cool Dwarf record report. No children bottom up. Oh, there you go. That's a flame graph. Your language is called OCaml. No, my language is not called OCaml. My language is called Cast. Flame graph. Flame graph PL. Is that what I am supposed to do? Okay. Flame SVG. Firefox. Flame SVG. Is this good? Let's see. This gives me a flame graph. All right. Can I So yeah, we evaluate. It's not very helpful. A camel C call. Camel BA create, whatever that means. BA alloc. So a lot of allocation is happening. That makes sense. Camel function eval. Camel common function. List find map. This like profiling data is useless. I already knew that my evaluation is slow, right? Am I vibe coding my language? No, why would I be vibe coding my language? No, I'm not. I'm proper coding my language. This data is useless. Let's look over here. Natives. Source of a camel. Yuri of string. Well, I mean, the fact that source of a camel is a function that is pretty high. I mean, that is relatively high on my thing. Parse big string. So it's because I'm parsing the Uris. So but the reason I'm parsing the Uris, so like right now, for every value that is created in the language, I'm trying to remember where this value was created. Which is why I'm creating Uris a lot, I guess. That kind of makes sense a little bit. So it is just Yuri parsing everywhere. Is that right? So basically, let's take a look at the code. Let me delete all of these profiling things. I'll save it in the just file in case I want this again. Delete these files. Profile. So yeah, basically what is a value in my language, right? We have the value. Values are potentially not inferred. Values are potentially not inferred. Can't you just use the hash code instead of creating a Yuri? I feel like it should reuse the existing Yuri is the only thing, actually. It's because we've seen Avocamel, right? The thing. I want span of Ocaml, right? So this is in the natives. All of these things, right? So let's say that I'm calling a function, right? Yeah, and span of Ocaml is like creating the yeah, it's like parsing the Yuri here. So like I can just create this once. Can I create this once though in Ocaml? I cannot have a constant here, right? Like I want this position to be here. The position is expanding to the actual like thing, right? Like I can create this constant outside of this function, I guess. I mean, I guess, sure, let's do that. Let's just say that span is avocamel position. You already get a string. Why do you need to parse it? Because I'm storing Uris, not just strings. My file names can be like yeah. I'm just storing like Yuri because that's more structured way to store the paths, I guess. And it's not just a string. But I think over here I'm just going to say span for all of these. span. Let's see. And now we are going to have like the span is not yeah. Span is a vocamal position. Then ditch the URI parsing and append the parameters by yourself and check the profiler again. I'm just going to like not parse the spans here, because like the only places when I'm parsing the spans is when I am like starting to parse the file, right? And over here, this is in the natives of the interpreter. This is where I'm creating them all over the place, because I'm trying to like literally like, well, like it basically creates the thing where like if I print it, it will give me access. It will like point me to this code instead of my cast code, right? Yeah, like it's a span like over here, literally, right? This also could be like a preprocessor thing, I guess. But still, like, since I need to call this function, this is like a performance bottleneck, we need to like get rid of it. Yeah, that makes sense. Let's just do that. I mean, you know what? Let's just say that there is a span here, like in general, span is span of a count. So like everything is just going to point to this line. It's a little bit less precise, I guess. Instead of like pointing me to like the body of this function, is going to point here, but that's already like whatever, I suppose. Right? Let's see. So just going to say cast projects that don't have code day 2. Let's see if it's going to be faster now. Well, I mean, I think this was faster, right? It's probably, you know what? Let's do this. Let's do git stash, right? And then we do this, and then we time it. Well, I mean, it probably should be done when it's already compiled. So this is 4.7 seconds git stash pop. And this is 4 seconds. So okay, this removed 1 second from it. I wonder if you could avoid using spans everywhere and somehow infer or get spans lazily when needed. This removed 1 second, which is not too bad, right? That's 20% improvement in speed, right? Let's try profiling it again. Let's profile the example now. Maybe if it's not that big, it's going to actually open in the Firefox thing. Yeah, this is just 120 megabytes now. Yeah, this actually works. Maybe this website just couldn't load the huge file. Yeah, we have the evaluation. 62%. Wait, over here it went from 62 to 46 because this, yeah, okay. And this goes back to evaluation. Yeah, okay. What's the good thing here? Make flame graph. Okay, that's flame graph here too. This is still all just evaluation. Can I like call tree in vertical stack maybe? Like boom 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 boom. What is this thing over there? You see how this over here starts to be more yellow after 1.3 seconds? Sample than this, and this is my stack and this thing. What do these colors even mean? Script native. What is native? All frames. Oh yeah, I see. I understand. Yeah, we just use all frames here. Stack chart. What is stack chart? Why is this just all yellow? It's like inverse flame graph. Does cast only target with JS? No. We I mean cast itself does not I mean cast itself only targets the JavaScript only targets the interpreter right now, right? So yes, I guess yes, you can only like run it in JavaScript with the interpreter, which is compiled with JS of OCaml. Yes, 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 yes. There are other backends planned, but they are not there yet. That's probably like one of the next things that I'm going to do. Not the there's still a couple of language features that I want to add, and then maybe the transpiler. Exceptions, a bit archaic, but I guess they are rather straightforward to implement. What does that mean? Hello. They're saying that I should add exceptions to my language. I mean, I guess I don't have exactly exceptions, but yeah. How to use this thing? Flame graph. Let's see. So there is still like the eval everywhere, right? But now we are inside the eval. Can I like zoom in onto this thing? Focus on function. No, that doesn't zoom in. Can you zoom in? Merge function. Merging a function removes it from the profile and assigns its time to the function that called it. Collapse function, collapse recursion, drop samples. Focus on subtree only. There we go. Yeah, so we have still eval. Eval is calling eval. There is still, this is still eval. Focus. Inference, inferred values, source fake. Oh wait, is this the correct? Is this the one? This is still parsing URIs. Okay, it's because we have source fake. Okay, let's see that now. I have a thing that's called, I guess it's span fake. Let fake. Let fake. Fake is beginning of URI of string this. There you go. We have a fake and we have description. Okay, and then span fake underscore. Sure. Let's call this span. Let span be this in that. Let's do this on the Let's do this. Let's say unite is this in function AB into that, right? There you go. This way I create this pen only once. Are they implemented with some kind of result type that simply propagates error upwards, or like C++ where there's an exception handler table? They are not implement. I mean, I don't have that yet. I only have the interpreter currently. I'm not compiling my language. And the way I have something similar to exceptions is they are implemented using the exceptions in the language in which the interpreter is written. So I'm using exceptions to implement exceptions, basically. When I will be compiling it, then it also depends on the compilation target, because one of the first compilation targets that I'm planning on having is the JavaScript. And in JavaScript, we already have exceptions, so we just use exceptions to implement exceptions once again. And then when I actually target the native code, which is also planned, but probably in the far future, then we will do it either with the exception handler table or with propagating. I mean, we need to propagate it upward. We need to unwind the stack because we need to like call the destructors. I mean, I don't know how C++ implements this exactly, right? But there is the exception handler table, but like you still need to unwind the stack in C++, right? You need to call the destructors of your things. So yeah, it's probably like the result type, although I think it's not the result type because like it's not only exceptions that I will have, I also need the delimited continuations. And so we will probably, like when compiling to native code, I will rewrite my functions into the continuation passing style. And so basically, like, yeah, I want effects in my language. So yeah, we do the continuation passing style, and we have like two continuations: the successful continuation and the unwinding continuation, or like I don't know, something. I'm not sure yet exactly. Right? I did not think about it too much, but it's probably going to be continuation passing style anyway, because that's how you implement async, right? Stuff. That you would need to, yeah, because when you want to capture the continuation for the effects. Yeah. But for now, since I'm writing OCaml, once again, in the interpreter, I'm just going to implement the effects using the effects, because OCaml is a language which already has the effect system. So I'm just going to go the easy route in the interpreter and implement effects with effects. Just say improving performance. I want effects to be statically typed, not like in OCaml though. I want it to be closer to like proper languages with effect systems. It's not implemented yet though. I will probably like do that only after I bootstrap. You have your own unreleased language with effect types like that? Yeah. Effects are nice. I think all the languages should have them. Now, there's a lot of new languages coming, and like a lot of new languages have the effects, right? I think it's a good thing. Learn soundness or performance problems very quickly. For example. Well, I mean, soundness or performance. I mean, I can see the soundness problem because, like, as you make functions and effects second class rather than first class. Yeah, I'm not sure what you mean exactly. Hello, Brooke Zerker. Thank you for the raid. How are you doing? means you can no longer store or return functions. I don't. I mean, I did not look into it too much, maybe. But what is the soundness problem? Or performance problems? Hello, Chantilly Cake. Welcome. How are you guys doing? Do you solve the advent of code? Coffee drinker. Hi. So I already solved the advent of code day 2, just not so long ago. And right now I'm trying to profile and improve the performance of my language, which is what I use to solve the advent of code. I have my own programming language. Over here, this is over here is the solution for the day 2. That's what my language looks like. And it's kind of really slow right now. It's interpreted. Because functions can be factual, and if you just return them, they might contain effect handlers that no longer exist, and they will crash your program. That's why you want it to be statically typed. Yes, that's why I'm saying. That's why it should not be a language like Camel. That is easy to do. Yes, I agree. But what I am looking for is a language like Coca, for example, which has the effects in the type system. So like when you have your function main, you can see that this function has access to the console, so you can only print to the console from inside that function. And if the function was not having this in its type, then it would not be able to print anything, basically, right? Similar to the monads in Haskell. Coca has that problem too. Does it? What about all the other languages? Is there like an issue for it? Because I'm pretty sure they fixed it with adding new effect types later by scoped and named effects. So they don't have the problem, right? If they fixed it. So, in theory, the proper implementation should not allow your effectful functions to escape into the areas where the effect handlers are no longer present. As long as you use scoped effects, it shouldn't be a problem. I mean, yeah. Like, the proper implementation should not allow that thing. That is a soundness bug, yes. If that is possible. What is unscoped effects? I mean, yes, I want to use scoped effects, I guess. Thankfully, there is no system of Coca libraries. It would have been an unfixable program if it was a popular language already. I don't know what you like. Maybe you looked at Coca earlier than I did, when their effect types were not scoped and not named, I guess. Because when I saw it, it was already like named and scoped. What about the other languages with effects like Flix, for example? Right. They have effects like this. What about the other languages? I don't know. There's a lot of languages. What are the other ones? There's more. Does Parlang have it's not the one, right? Parlang. This one. Does this one have effects? I don't remember. This one has linear types. And like linear types and effects is also like making it a little bit more difficult, by the way, right? So, but I also want to have that, the linearity. Does this one have effects? They don't go well together, but it's still possible. It's still possible. I think they are actually very nice together, but it's not as obvious as just like you know. Anyway, I was trying to improve the performance here. Boom, 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 boom. To do performance. That's not the one. It's about span fakes. Yeah. Span fake. I need to like look at all of these. Single character, fake description. That's the definition. Okay, let's go here. This is the inference, new not inferred value. Span, sure. Wait, what? This is what? This is a different span? Wait, hold on. What was here? Infer value based on type? Ah, yes, yes, yes. I've been working on that problem and was even going to release a paper, but I have to pay bills, so yeah. Yeah. There is a Eduardo who is streaming on Twitch. You probably know him, right? I'm assuming. Since you know this much. He's making a language with linearity and effect systems too. It's a lot different from what I'm making, I think, but yeah. I'm not the very much very deep in the theory stuff, so I'm just like doing things. I know what I want, but I don't know how it's done normally. So I'm just like reinventing the things as I go here. I just know what effects are because I've seen a language that has them. Span. I want like and infer as this. Span is I mean, I just have span here. Like, it doesn't really matter. Type of value shape. We create this span outside of the function. Make it be like that. Transpile, that's the transpiler. Substituting should not be happening, and whatever is happening in the compiler doesn't matter. In theory. Okay, so let's try doing this again. Let's see if this works 1,000 times faster now. Did it work a lot faster? It did. Is this not like... This is twice as fast as it was running before, right? Look at this. Git stash. Let me remove the perf. I mean, it doesn't matter, I guess. Let's do git stash. Time it. After it's built. Yeah, this was working for 4.5 seconds. And now it's working for less than 2 seconds. That's good. You know, linear types and effects, you're already deep in the rabbit hole. Normally I've been using Rust for a long time. So there's also a bunch of features from Rust that I would want. So we will. Yeah, I don't know, like, I don't know, I mean, yeah, I know what effects are, but like I said, the reason I know about them is because I just looked at Cocoa one day for some reason, and that made me interested in seeing a language with them. Why a proper LSP when you have OCaml LSP with fake errors matching your fake friends, huh? Span. Okay, let's see. Improve performance X2. That's it, right? I think that's enough performance improvement for now. I'm maybe like doing more profiling. I will like figure out something more. Actually, no. Let's actually profile again. Profile. Let's do profile. Fine. I'll profile again. Yes. 4.70 to 1.9 is not bad. Yeah, but like ideally, like, well, I mean, I guess I will never like reach the Rust level, like of your solution with regex, or was it not you? Someone else was doing Rust with regex, which works in just like 0.2. And but this is the example. This is the example. This is not the actual input. So the this should actually work in 0 time, right? But yeah, it still is interpreter, so it's never going to be like that fast. All right, let's open data perf. So how do I use this again? I click all the things. Click. It's easier to see it on the flame graph, I guess, still. So we just have eval. It's just like, is it just because I'm calling the eval so many times? This over here is still source of OCaml, by the way, which is weird. This is 2%, which is 37 milliseconds. This is called from inside cast interpreter common list find map. Cast interpreter common. Wait, what? Is there a position? There is a position. All right, there you go. This is finding target dependent branch. That makes sense. Finding target dependent branch. Probably when I'm having like in my standard library. So like what happens, right? Let's say that I want to just compare two integers right now. Right? Because I'm doing that a lot, right? I'm doing like math in this thing. In the advent of code, right? So we're doing operator add. So in order to like do this, I'm actually interpreting this code. So I'm supposed to have the transpiler into like other targets or like compilers. But in case we are running the interpreter, then we are calling the native function, right? So so yeah, this is like more expensive than it should be, right? So yeah, we do that. Also, this can be improved. We can do this is equal now. Yeah. So and because of that, in my interpreter over here, there's more span. So it's all spans. Okay. Let me see. Find target dependent branch. I just say over here that span is span of OCaml position. And then over here we have span. And then we have span. There we go. Is there any more? This is the only one, right? In this place. Let's time it again. Is it going to be like 1 second now? Let's see. It is 1.3 seconds now. Okay. Okay. Nice. Let's profile again. How do I like upload local profile? Share performance profile. No? Do I like need to go back? How do I like reopen the website? There like no button to like open a new profile? Flame graph. Let's see. Common eval. Cast interpret a common function. Eval. Maybe like at this point I cannot make it faster. I'm not sure though. Like camel string compare. A lot of string comparison happening, right? Call camel uniform array make, creating new arrays, allocations. But where exactly? Focus on sub-tree. Okay, it's tuple. Cast util tuple. Cast util tuple. Map I. I mean, I guess it kind of makes sense. Astlib array map I. Tuple map I. So like right now, when we are seeing the code like this, for example, right? So this is a function set.add, right? This is a function that takes as argument two arguments, which is s and x, right? So this over here is technically just a tuple of two fields, right? And sometimes I'm naming my fields too, although it seems like in this code maybe I'm not. What about like standard library? And like operator. This is also not named. Yeah, I guess. I don't know. But let's take a look at tuple. Tuple map I is this function, right? So I'm saying unnamed is a named map I this. Yeah. But wait, but where is this called? Array map I, because I'm evaluating this thing. Inference impl inferred value. Inferred value, like I'm creating values. I mean, like one of the problems is that like I need my values to be inferable, but it's not necessary for like a lot of things, so I'm going like through these interactions, which makes sense why performance is bad. Let me just improve performance more. Maybe I should just ignore these things, since this is actually usable now. Let's say ignore perf data and perf data old and data perf, right? Ignore perf data. Yeah, so like it's the tuples that are here a lot. But wait, but the reason they are a lot here, like look at this, right? This is over here a tuple. But in tuple, the reason the map is slow is because I am evaluating something, right? Map is a thing that's calling a function for every field. And it's calling these functions, which is slow. Which makes sense. And then over here, this is a find opt. So this is finding a variable in the scope. Oh wait, I know another performance bottleneck probably. Like when I'm trying to find a variable in the scope in the interpreter, I'm probably going like through like to parents a lot, right? Because like let's take a look at this code, for example, right? We say over here like I don't know, times, right? Where is this times defined, right? Well, it's defined over here. In order to go here, like you would think that it's just the times is just like in the parent scope of the current scope, right? But it's not, because every time we do a semicolon right now, I think I'm creating a new scope because of the because of reasons, right? So yeah, I think so. So like let me actually make a test. I think it's kind of easy to test. Search top level first might be smart. It's not top level first. I can just reduce the nestness, I guess. Is one thing. How would you how could you also do this? Like we do have the compilation stage, right? So how would you do this in like C, for example, right? You would I mean, yeah, it's a little not trivial like this. Oh wait, am I actually doing this? I'm not sure. Let me see. Let me see. Let me see. Yeah, like because we need to do things. Let's take a look at the interpreter, like in general, right? Like when I'm interpreting the expression then, right? So this is the expression which is semicolon. No, I'm just evaluating this and then I'm evaluating that. I'm actually not doing that. No, never mind. I'm doing that in the compiler probably though, or something. I'm not sure. I remember something. And but how am I looking for the things anyway? I mean, I think I'm not doing like it based on the string in the interpreter because I already have the IDs. So it's not like the string lookup. So we have a scope, right? So this is the local scope, and I'm trying to find this. I'm using the symbol map. I'm looking up the name. Name is a symbol. Symbols, they have IDs. So while I'm looking this here, symbol map. Is map make symbol. Compare. Yeah, we're just doing this based on IDs, and IDs are just numbers. This is just integers. Yeah, so like it's faster than than it could be if I just did lookup by the name. Okay, well, I don't know. I think I need to look at the profiling data more. But it seems like everything that I see is the eval function, which makes sense, right? Like I'm evaluating all the time. Whole tree. Can I reset? Like, why am I looking at this thing? Complete cast. There we go. Camel run stack. Cast interpreter eval. Eval with return. Function eval. eval, 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 eval. Like, I want to see anything that's not eval, basically. Can I? Can I, like, can I just do by self time? There is total samples. What is self? Self sample count only includes the samples where this function was at the end of the stack. And this is only like string compare. Does it mean that I'm doing the string compares too much? Would be nice if there was an array-backed hash map so you could use for scopes. So to make sub scopes, you just append to the root. I don't know if that works. It seems you never modify parent scopes, which I'm not sure about. Yeah, no, I'm modifying the parent scopes. Yeah. Hello, Elemental Magic's card game. Also think about like closures, right? When you create a function, we are doing a closure. And what I'm doing right now, I'm just capturing the entire scope. I'm just having a reference to the scope where the function was defined, right? That scope is definitely going to be modified like further down, right? Elemental Magics. Did I say hello? Hello. And welcome back, Penguin. Flame graph, stack chart, marker chart, marker table, all tree. Eval, 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 eval. Eval, eval. Wait, this is 0. I don't want to look at zeros. I want to look at this. 50%. 50%. Eval, 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 eval. Eval, 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 eval. Eval, 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 eval. I mean, this also seems like a very deep recursion, right? It would be nice if I figured why is the recursion that deep, right? It's interesting that I'm not overflowing my stack here. Or is this like still like this if we do the tail recursion? But my recursion is not really tail. Like look at this in the like evaluation. Common. It's not really tail recursive function. The function eval. Where's my function eval? It's called eval. Hello? Oh, it's the other file. We need the interpreter. Eval. Eval is a function which is like trying to evaluate the result and then like traces it before returning, which and this makes it to be not, and also like we trace the exception, the stack trace if we throw an exception, so this makes it to be not tail recursive anyway. And then we are having the thens. So like if I have a bunch of statements after each other with a semicolon, then that's going to make me be deep in recursion. Yes. So we can like I can, for example, change the my expressions to actually this be a list of expressions, right? Instead of just being the semicolon being the binary operator, we can actually convert it into a list. That's not too difficult. Static scope size would be a nice property, but would require pre-computing sizes. I mean, maybe it's because I'm using a hash a map, actually. Let's actually see this. So here's my interpreter scope, right? This is symbol map. Symbol map is map make. Map is the ordered map, but we could instead use a hash map, which would be like But I don't think that's the actual problem, though. Like, I don't think I have, like, big maps. That's not the issue. I don't think so. Yeah, I don't think so. Depends on the type of tail recursion. Well, as far as I understand, OCaml, tail recursion is like just a jump. Like the profiling is happening using the built-in tools, so it would not be present in the stack trace visible to the profiler, I think. Even if when I'm throwing the exceptions in OCaml, it's not seeing the stack in tail recursive functions, I think. Not all tail recursions can be eliminated unless you write the code in a way that makes it possible. What? The tail recursion, if it's not eliminatable, then it's not tail recursion, right? It's called tail recursion because it's like the code that's written in a way that's tail recursive. If it's made in a way that is impossible, then it's not tail recursive, right? Not necessarily there are tail recursions and there's a proper tail recursions. Yeah? Let's look it up. Proper tail recursion. That's a new term. I never heard about this before. Proper tail recursion and space efficiency. Oh, there's a paper about it. Oh, look at this. A PDF from the 90s or something. Properly tail recursive. This is standard from the scheme that requires implementation for properly tail recursive. This ensures that portable code can rely upon the space efficiency of continuation passing style in other idioms. Proper tail recursion considers the efficiency of procedure calls that occurs within a tail context. When examined closely, proper tail recursion also depends upon the fact that the garbage collection can be asymptotically more specific than Algol likes. Allocation proper tail recursion is not the same as ad hoc tail call optimization in stack-based languages. Proper tail recursion often precludes stack allocation in variables, but yields well-defined asymptotic space complexity that can be relied upon by portable programs. Paper offers. I don't wait. What? What's the difference? I don't get it. What OCaml mostly does is that it can eliminate the tail recursion. It does. If it can eliminate the tail recursion, it does. Otherwise, it uses trampolining into the heap, not crashing the stack. What does that mean? What does it mean to do proper? To eliminate the tail recursion? Like, and how is trampolining not eliminating? Like, it's trampolining is still not recursion, right? So it's no longer recursion. At least, right? So there is still an optimization, which is not like you still give up the stack of the current function, right? Or are you saying like trampolining into the heap, not crashing the stack, so like you still keep the current stack around? Is that why my LSP is leaking memory and my stream is crashing? Hold on. Is that because OCaml is doing something? It's like keeping the stack around? Aren't you essentially converting recursion to looping? Well, when it's proper tail recursion, I guess, right? Trampolining basically makes a new call stack on the heap instead of using the actual stack. Yeah, but where does the old stack go? Like, doesn't the old stack is just going to be garbage collected, right? or what is happening to it. So or is there something, or is it actually leaking memory? Because I am leaking memory in my language currently. Somehow it will keep eating memory. Is that actually what's happening? Can I debug that? Can I stop leaking memory? Is OCaml a language that if you write it without knowing it, you will just leak memory? Where can I read about this? OCaml trampolining. Trampolining. Implement trampolining. No, not implement. Creating stack for a heap with trampolines. And monad in OCaml. Trampoline OCaml. JS of OCaml compiler. What is trampoline? Lining. Tail recursion. In OCaml, trampoline is a technique used to achieve tail call elimination in situations where direct tail call optimization might not be applicable or desired, particularly when dealing with mutually recursive functions or when working with monads that don't inherently provide tail call optimizations. Why trampolining? Well, OCaml excels at tail call optimization for direct tail. Okay, so it's when you have mutually recursive functions. Yes, that like makes sense, but like it still is. So like when you have two mutually like, is it as easy as like having two mutually recursive functions and you immediately start leaking memory in OCaml? Trampolining involves transforming a recursive function into a series of bounces, which are then executed by a central trampoline loop. Instead of directly calling the next function in a recursive chain, the function returns a data structure containing the information needed to call the next function. The trampoline then repeatedly extracts this information and calls the appropriate function. But wait, hold on. But if this explanation by the AI is correct, then it means that we are doing the recursive function by returning from the function that we need to do the tail call, basically, right? That's how it's implemented. So, which means that we are going up the stack instead of just doing a jump, which is the proper tail call optimization, right? I only see performance issues with that, but this is not leaking memory. The thunks are in the heap, the rest is in stack. Yeah, but like, what's the thunk? In a series of bounces or thunks. I mean, yeah. I mean, the thunks are in the heap because that's the data that is basically returned from your function, right? So like everything in OCaml lives in the heap. That's fine. But like you return from the function. So what is in the stack? And I'm not overflowing my stack, which is mean it's not the stack that grows infinitely for me. It's the, or you mean like the stack, like it, you said it constructs the new stack on the heap, which just is living forever. It's like weird. Like I don't think, I think it's me who is leaking memory. It's not OCaml, right? But you're saying that OCaml can leak memory. Can you give me an example, or is there like a link that you can give me to how it would be keeping eating memory? Because that's maybe what I'm doing then. OCaml keeps eating memory. Data structures and cycles. Cycles and data. Garbage collection, memory leaks, unreachable objects. While OCaml uses a garbage collector, memory leaks can still occur if objects are no longer logically needed but remain reachable through references, preventing the thing. Yeah. Large intermediate data. Program design. There's nothing here about the like trampoline. If it is the main program loop that's long running, it can happen. Okay, well, you're still not giving me a specific example, I guess. So, like, but sure. Okay, let me... What was I doing before I was looking at OCaml? I don't think I should blame OCaml for my memory leak. It's just that you are making me wonder if I should blame OCaml. I was profiling. I was going deep into this. Eval. Assign. Wait, no, this is 0.1%. Eval. Can you like go deep immediately, like to anything that's not eval, please? Every time it has like with return, every time it shaves 5%, but inside of the return, it still is eval, right? Oh wait, look at this. Wait, hold on. So we have this 4.9%, and this is the, oh yeah, it's like with return here again. Yeah, okay, never mind. Sequence folder. Tuple. Common function. Map union. Map union. Da-da-da-da-dum. Is that because no? It's all just eval. Oh wait, instantiate. But it's 0.7%. Instantiating. And over here, find opt takes most of the time. Compare value. Yeah. Yeah. You cannot give specific example because it's not really a language issue, but a memory management issue. Is it? Well, I mean, if the language allows you to leak the memory, then isn't it I mean, like you say if you write it, I don't know. Like, I'm not leaking memory on purpose, right? So it should not be leaked, basically, because otherwise it's a language issue. Least find map. Where am I doing least find maps? That's a lot. That's 5%. Least dot find map. List dot here. List dot find map. Interpreter. When I'm doing a match. Oh, maybe it's just a match. Oh wait, I mean yeah. Pattern matching right now is done like linearly, which I don't know if that's the thing. Yeah, and I guess target dependent branches. Yeah, that makes sense. It's a target dependent branch. That makes sense. Because I'm like, for all of my math, I need to like find the thing. Yeah. Are you just recursively calling eval in your eval function, by the way? Well, I mean, I am calling it recursively, but it's like, I mean, like, I'm evaluating an expression, right? Like, let's say that I'm evaluating a function call, then I'm just evaluating the function, evaluating the argument, and then I am like applying the function, right? That's all and all of these things like call eval recursively, right? But once we have evaluated that expression, we should just move on, right? So, I mean, yeah, it is recursive. Why would it not be recursive? Because the language contains expressions which are containing expressions inside of them. I mean, I could have the my own like custom stack and like unroll like that myself, I guess. But just doing it the simple way. But I could, I guess, yes. Have the stack. Something. For debugging reasons. Actually, I'm not even sure that if I can, because I'm also like using a bunch of things like effects. There. I mean, what I should do to make the interpreter faster is make a JIT, right? So like, I should not be doing a lot of things that I'm doing right now in the interpreter, like pretending that every value is inferable, for example, because not everything is inferable. But we're just having the generic thing. Not necessarily a JIT, but when you end up with some kind of bytecode in practice. Well, I mean, a JIT is not like we can have like a JIT which is just in time compiling into like maybe like not native code, but something that is like more lower level and it is faster to interpret, at least. You know, like if I have enough data for it, but it's not always possible. Like I said, one of the things that I'm doing is I'm treating every value as inferable, right? And that's not needed in 99% of cases. So that means that when I'm trying to actually investigate the value, let me show you here. So we have inference here, right? So every time I want to look at the value and see what it is, I'm doing something like this, right? I'm trying to find the the actual value, which is like going through a bunch of like indirections through the DSU data structure and stuff. You know, like it's yeah. But yeah, like I should do something like when everything that is needed for the function. But I mean, why don't I just use a JIT? Like that's something that is possible for sure. Yeah. Like there are probably like libraries in OCaml that would allow me to do that. Anyway, what was I doing? I had a thing that I wanted to do. Oh yeah. Like for example, right? Let's give a simple example of what I can do. Just I mean, maybe like not just in time, but like pre-calculate. Here's my, once again, this is the addition, right? So this over here is a function that takes two values and adds them together, which calls the native plus function directly, right? But every time I call this function, I'm trying to see if I'm in the interpreter or anywhere else. You know? So I'm constantly comparing strings. Is comparing of the strings like this in OCaml, because this just corresponds to OCaml comparing the things? Is that linear? So like, is it just like very slow because I'm comparing the string interpreter to the string interpreter all the time? That might be the case. Because it's not like, are the strings like, what's the term when the same string is like only present once in memory or whatever? I don't think that's happening, right? So this is what's hurting my performance a lot. There is simple fix, compare integers instead. No, I think I should like just pre-calculate the one for the interpreter, because like for all the other targets, these other targets are like the compilation targets, so I'm going to like evaluate this only once, but interpreter is the one that's doing it a lot. So for every like expression that is done, that is like the target dependent, I should pre-calculate the branch that I should evaluate in case I'm running the interpreter. That's it. So we have a expression. Find target dependent branch. Expression. Yeah. Value target. Yeah. Yeah, we should just assume that's true, and we'll just we'll just use the pre-calculated thing. So here's we have types, right? We have expression target dependent. So for every expression like this, we have the branches, right? But there is one branch that is the important one, which is the interpreter branch, right? But the interpreter branch is the one that we should basically yeah. Interpreter branch. We just keep the reference to the branch, right? Standard dependent branch. I guess option then. And this should be like mutable or something, so we like assign it at some point. Actually, yes, we just make it mutable and then we try to find it. So yeah, we just do it just in time. When it's needed, the first time we calculate it, and the other times we just use the existing branch, right? Yeah, that's what we mean by just in time here in this case. That makes sense. Printing interpreter branch, ignore this. So yes, over here, this is the interpreter, right? When we have the interpreter branch here, right? So we find target dependent branch. Is this used in other places? Let me see. Find target dependent branch. It's done in the transpiler and like over here. Yeah, so over here we just say chosen branch is if I'm going to, I guess, match interpreter branch. Can I say over here this as expression, as a target dependent expression? So match interpreter branch with some pre-compute, like some computed, then we just use the computed. But if it's none, then we actually calculate it, right? We say that let computed be this. So we calculate it for the first time. So we're trying to find the interpreter branch. And then I just say that target dependent expression dot interpreter branch is sum computed. There we go. And then we return the computed here too, right? Like this. So that's a just-in-time thing basically, right? Compiler initialization. I guess I don't do that. Anything here? Branch. I think it's going to like go really fast now. Maybe not. I don't know. So in the compiler, when I compile the thing, we initialize it with none. And then the interpreter is going to like initialize it at some point. That makes sense. Okay, this is working. Less than a second. What was my last time? How much did I improve performance right now? But we already went from almost 5 seconds to less than a second. Yeah, it was like 1.3 seconds here. Yeah, 1.3 seconds. Into 0.9. Nice. More performance. Nice. Let's should I keep profiling? Should I make it like it should still. This is still a very small thing, right? I think this should still work like 0.1 second at most if it's done properly. Just profile. But it's already like really hard to see anything here, except for the evals. Eval with return eval. Like, I feel like what I can, like, maybe at this point, maybe it would be easier if I was like measuring the time myself in terms not of a camel code, but in terms of cast code, right? So I know what code like in cast is slow, right? Which lines took the most time. And we'll probably like I need to probably do it in the same format that is like used in all of these existing profiling tools, so that I could just load it over here and just see it. Maybe, I don't know. That's probably not something that I should be doing today. I mean, there's yeah, no, mind. Yeah, I kind of like really want to look into that. That would be really helpful. Like how much time is spent in the native code of the interpreter, how much time is spent like Bum 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 bum. All right, what time is it? Maybe that's like enough improvement for today. I don't know. What happens if I just run this thing, like on the actual input? Test like input txt, right? Because I was waiting for like a minute previously, and now it should be like just 10 seconds, probably. Yeah, it's just like 9 seconds instead of being a minute. Because I made it like more than 5 times faster, right? Yeah, insane improvement in a day. Yeah, I think I would like if my performance is good enough for the advent of code, I like it. I should delay this for later, and instead I should work on the language so it's like nicer to write. Right now, one of the most hurting things is the LSP being a little bit too slow. So the LSP was really fast, but it was working incorrectly. And now it's working correctly, but it's slow, and that's because right now on every change I'm recompiling the entire standard library, and I should not be doing that. Yeah. But that's probably also not the easiest thing. I need to like think about how to do that properly. Like the problem is that I'm mutating my standard library like via type inference, and it breaks the types there. Yeah, I think let's just call it a day. I'll go rest. See you tomorrow. Let's see who else is doing something interesting. A lot of Zeke people lately.
So this is gonna be...
Go here. Thank you guys for watching. See you next time. Bye.